Betul, betul. Betul enggak?
Mira Septikawati,
as a master of ceremony on the event, the NINS of Icetia International Conference on Engineering, Technology and Industrial Application 2022.
and the 21st of Rapi, Rekayasa Aplikasi dan Perancangan Industri.
Recording in progress.
The theme for today's event is Process and Product Design Innovation Towards Responsible Production and Consumption, which held in online will not reduce the knowledge and information that delivered by our speakers this morning. Ladies and gentlemen, on this occasion, allow me to introduce you to our today's agenda. The first one, there will be opening ceremony.
Second is recitation of the Holy Quran.
Third, singing Indonesia Raya and Sang Surya.
Fourth, opening speech.
Fifth, break and panel preparation.
Sixth, panel session 1.
There will be announcement.
Eighth, panel session 2.
The ninth, there will be lunch break and Zuhur prayer.
The 10th, parallel section.
And closing for day 1.
Entering the first event, let's start the NINS of Icetia International Conference on Engineering, Technology and Industrial Application 2022.
And the 21st of Rapi, Rekayasa Aplikasi dan Perancangan Industri.
This morning, by reciting Basmalah together. Bismillahirrahmanirrahim.
Second agenda is recitating the Holy Quran that will be read by Andi Resti Maharani. To Andi Resti Maharani, the time is yours.
Assalamualaikum warahmatullahi wabarakatuh. A'udzu billahi minasy syaithanir rajim. Wa idz qala rabbuka lil malaikati inni ja'ilun fil ardi khalifah. Qalu ataj'alu fiha man yufsidu fiha wa yasfiku dima' wa nahnu nusabbihu bihamdika wa nuqaddisu lak. Qala inni a'lamu ma la ta'lamun. وعلم آدم الأسماء كلها ثم عرضهم على الملائكة فقال أنبئوني بأسماء هؤلاء إن كنتم صادقين. قالوا سبحانك لا علم لنا إلا ما علمتنا إنك أنت العليم الحكيم. قال يا آدم أنبئهم بأسمائهم فلما أنبأهم بأسمائهم قال ألم أقل لكم إني أعلم غيب السماوات والأرض وأعلم ما تبدون وما كنتم تكتمون. صدق الله العظيم. اللهم ارحمنا بالقرآن. والسلام عليكم ورحمة الله وبركاته.
Waalaikumsalam warahmatullahi wabarakatuh.
Thank you to Andi Resti Maharani. I hope that the recitation of the holy verses of Quran and the Sari recitation can provide great benefits for all of us. Amin.
The third section is singing the Indonesia Raya and Sang Surya.
To thank you for attending the 9th Icetia and Rapi 21st, 2022. I must also express our gratitude for your participation. For your knowledge, this conference was first held at the national level in 2001 by the Faculty of Engineering at Universitas Muhammadiyah Surakarta under the name Rekayasa Aplikasi Perancangan dan Industri or Rapi. As the international version of Rapi, the first international conference on engineering technology and industrial application, or ICTI, was organized in 2013. Since then, both Icetia and Rapi has been held concurrently. This year, Icetia and Rapi are attempting to present some integral technical breakthrough, particularly those relevant to process and product design innovation toward responsible production as the main topic of the conferences. As we acknowledge, both process and product design are equally important to fulfill the modern demand. Product is the final result of a sequence step of the process. To obtain qualified product, it is vital to design the appropriate processes. And this is the main idea of the conference topic. This year, the conference held virtually and welcome contribution from engineering areas such as electrical engineering, industrial engineering, mechanical engineering, chemical engineering, and other engineering domains with relevant ideas, concept, application, best practices, and research. We'd like to let you know that, like this year's event, Icetia intends to publish its article in Scopus Index Journal and Proceeding. We received a significant number of submissions for both conference series, 29 for Rapi and 99 for Icetia, but of which only 92 papers we accepted. This year, we are going to publish the paper in Scopus Index Conference Proceeding. A few selected papers will be promoted to 4 Scopus Index journals. There are Journal of Islamic Architecture, Civil Engineering and Architecture, International Review of Spatial Planning and Sustainable Design, and Scientific and Technical Journal of Information Technology, Mechanics and Optics. On behalf of the 9th Icetia and Rapi 21st, 2022, I'd like to convey my heartfelt gratitude to the following 4 distinguished speakers: Professor Dr. Walid Franky Faris from Department of Mechanical Engineering, International Islamic University, Malaysia; Dr. Fatwa Firdaus Abdi from Institute for Solar Fuel Helmholtz Zentrum, Berlin, from Berlin, Germany; and then Dr. Yudi Aryadi from School of Mechanical, Aerospace and Automotive Engineering, Coventry University, United Kingdom; and then Associate Professor Muhammad Mujibur Rahman, PhD, from Universitas Muhammadiyah Surakarta, Indonesia. Special thanks for our partner, Faculty of Engineering, Universitas Muhammadiyah Kalimantan Timur, Indonesia. And then finally, again, I'd like to thank all of the presenters and attenders for joining this conference. Also thank you to all of the committee members who worked so hard to make this event a success. I hope you have a good time during the conference. Inshallah, we hope to see you in Surakarta for next year. Amin. Assalamualaikum warahmatullahi wabarakatuh.
Thank you very much to Dr. Agung Sugiarto, STME, for your delightful speech. May it be useful for us.
The second greeting speech will be delivered by Vice Rector 1 of Universitas Muhammadiyah Surakarta, Profesor Dr. Andes Harun Joko Prayitno, SAM Hum. For him, time is yours. The second greeting speech will be delivered by Vice Rector 1 of Universitas Muhammadiyah Surakarta. For Profesor Dr. Harun Joko Prayitno, S.A.M. Hum, time is yours.
Oke, ya, terima kasih. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh.
Alhamdulillah, alhamdulillahirabbil alamin. Wassalatu wassalamu ala Rasulillah wa ala alihi wa sahbihi wa mawala. Asyhadu an la ilaha illallah wa la syarikalah wa asyhadu anna Muhammadan abduhu wa rasuluhu. Allahumma shalli wa sallim wa barik ala Muhammadin wa ala alihi wa sahbihi wa man tabi'ahu bi ihsan ila yaumil amma ba'd. Morning, ladies and gentlemen from Indonesia. Firstly, alhamdulillahirabbil alamin. Praise to Allah Subhanahu wa taala who has given us his nikmat and blessing so that we could gather here today. May salawat and salam be with our Prophet Muhammad sallallahu alaihi wasallam who has guided us from the darkness and lightness in the world as well as in the next world. Pak Rektor cannot join this forum because he had other agenda. And then I would like to begin my opening remarks today by welcoming all the audience, honorable keynote speakers, Dr. Yudi Aryadi from Coventry University, UK, and then Professor Walid Wekri Faris from International Islamic University, IIUM, Malaysia, Associate Professor Muhammad Mujibur Rahman, PhD, of course, from Universitas Muhammadiyah Surakarta, Indonesia, and then to Dr. Fatma Firdaus Abdi from Institute for Solar Fuel Helmholtz-Zentrum Berlin, Germany, fellow WMS faculty members, Icetia and Rapi committee, and also all the speakers and participants in today's conference. It is our great pleasure to welcome you to the 9th International Conference on Engineering Technology and Industrial Application, Icetia, in conjunction with the 20th Rekayasa Aplikasi Perancangan and Industri, or Rapi. For this year conference theme, Process and Product Design Innovation Towards Responsible Production and Consumption has been chosen. The 9 Icetia and 2021 Rapi focusing on the latest research and practice related to the role of engineering and science, innovating process and product design to stimulate a society with responsible production and consumption activities. This conference is hosted by the Faculty of Engineering, Universitas Muhammadiyah Surakarta, Indonesia, in collaboration with Civil and Environmental Engineering Department of University Technology Petronas, Malaysia, and the Faculty of Science and Technology, Universitas Muhammadiyah Kalimantan Timur, Borneo, Indonesia. For your information, the 9th Icetia Conference is included in the conference series of the 8th International Summit on Science, Technology, and Humanity, or ISET, head by Universitas Muhammadiyah Surakarta, along with 9 other conferences. For this year, with academic improvement for recovery acceleration as its themes, the Icetia conference series, along with Icetia, have gathered more 900 presenters, exactly 941 presenters coming from 13 different nationalities. It has been demonstrated that Universitas Muhammadiyah Surakarta is on the right track as a respected university by the high level on enthusiasm among the scientific communities to participate in the Icetia conference series. Lastly, I would send my gratitude one more to all speakers and presenters for participating in this year 9 Icetia 21st Rapi conferences. Have an enjoyable and fruitful conference. I'm hoping that you could join us again in the next Icetia Rapi conference in the upcoming year. I would also to send my biggest appreciation to all the committee members of Icetia and Rapi on their effort in managing this year conference. We mentioned the name Allah SWT. Let's open together this forum with basmalah. Bismillahirrahmanirrahim. Nasru minallah wa kun qarib wa basyiril mu'minin. Assalamualaikum warahmatullahi wabarakatuh.
Thank you to Professor Dr.
Thank you to Professor Dr. Harun Joko Prayitno SAM Hum for his greeting. I hope what is conveyed can be useful for all of us.
Next section is for break and preparation for 10 minutes to preparing for entering the panel session 1. For all participants, please wait and be prepared.
Surakarta, atau dikenal dengan Solo, merupakan kota terbesar kedua yang terletak di Jawa Tengah. Dengan tagline The Spirit of Java, Solo menjadi kota yang sangat ramah dan penuh dengan budaya. Salah satu hal yang menjadi daya tarik masyarakat datang ke kota Solo adalah pendidikan. Didukung sarana pendidikan mulai dari taman kanak-kanak hingga pendidikan tinggi, Solo tetap mengedepankan pendidikan sebagai prioritas yang tidak dapat dikesampingkan. Universitas Muhammadiyah Surakarta sebagai Universitas Muhammadiyah ternama di Indonesia. Terletak di kota Solo, Universitas Muhammadiyah Surakarta telah mengabdikan diri dengan menyumbang sumber daya unggul kepada negara Republik Indonesia Sejak didirikan pada tahun 1958, saat ini Universitas Muhammadiyah Surakarta berhasil menempati 10 besar jajaran perguruan tinggi terbaik di Indonesia. Hingga kini, Universitas Muhammadiyah Surakarta telah memiliki 12 fakultas dan 60 program studi. Fakultas Ekonomi dan Bisnis, Fakultas Kedokteran, Fakultas Teknik, Fakultas Komunikasi dan Informatika, Fakultas Ilmu Kesehatan, Fakultas Keguruan dan Ilmu Pendidikan, Fakultas Farmasi, Fakultas Psikologi, Fakultas Geografi, Fakultas Agama Islam, Fakultas Kedokteran Gigi, Fakultas Hukum. Selain program studi sarjana S1, Universitas Muhammadiyah Surakarta juga menyediakan program pasca sarjana S2 dan S3. Untuk menunjang pelaksanaan belajar mengajar, Universitas Muhammadiyah Surakarta dilengkapi dengan sarana dan prasarana yang memadai. Universitas Muhammadiyah Surakarta, wacana keilmuan dan keislaman.
UMS adalah pilihan yang tepat bagi saya dalam pengembangan diri dan prestasi. Tidak hanya kegiatan perkuliahan di kelas, sederet kegiatan organisasi kemahasiswaan serta pendampingan yang dilakukan secara intensif menjadi alasan tersendiri bagi saya untuk tidak memilih kampus lain sebagai tempat melanjutkan studi. Universitas Muhammadiyah Surakarta, unggul mencerahkan semesta.
Alhamdulillah, saya sangat bangga menjadi bagian dari Universitas Muhammadiyah Surakarta yang terakreditasi unggul. Atmosfer akademik yang sangat kondusif, fasilitas lengkap, serta hubungan yang harmonis antara mahasiswa, dosen, maupun karyawan. UMS memberikan dukungan yang penuh kepada saya dalam mengembangkan prestasi saya.
Assalamualaikum warahmatullahi wabarakatuh. Universitas Muhammadiyah Surakarta adalah salah satu kampus terbaik di Indonesia yang menyandang predikat sebagai kampus unggul. Dengan dukungan sumber daya manusia yang sangat berkompeten, fasilitas yang lengkap, serta iklim akademik yang sangat baik, maka UMS berkomitmen untuk memberikan layanan yang terbaik bagi mahasiswa. Tidak hanya kemampuan akademik, tapi juga pengembangan soft skill maupun prestasi serta minat bakat mahasiswa. UMS unggul mencerahkan semesta. Wassalamualaikum warahmatullahi wabarakatuh.
Dalam langkah tegak, putra putri bangsa, berjiwa satria, berakhlak mulia, sebagai lentera menyinari pertiwi, insan harapan nusa dan bangsa.
Surakarta atau dikenal dengan Solo merupakan
We return to the forum to enter the core session, namely panel session 1. During the session, the panel will be guided by our moderator, Dr. Akida Mulyaning Tias, ST, MSc. She is our senior lecturer in Chemical Engineering Department of Universitas Muhammadiyah Surakarta. I immediately handed over to Dr. Akida Mulyaningtyas to guide panel session 1. To Dr. Akida, time is yours.
Okay, thank you, Tariq and Mira. Assalamualaikum warahmatullahi wabarakatuh. As mentioned before, my name is Dr. Akida Mulyaningtyas, and I'm from Department of Chemical Engineering, Universitas Muhammadiyah, Surakarta. And it is such a great honor for me to be your moderator in the first session. In this session, we will have two speakers. They are Dr. Yudi Aryadi from Lancaster University, United Kingdom, and Professor Walid Faris from International Islamic University, Malaysia. To start this session, here I would like to read the CV of our first speaker. Let me share the screen.
Ini yang Pati ini bapaknya wakil gubernur. Gitu. Nah, ya bapaknya wakil di bupati. Dan bapaknya anaknya yang pertama kalau nggak salah itu. Baru beberapa.
Ini yang jadi anu siapa?
I'm still struggling with the PPT. Okay, I think this is fine, yeah? This is fine. You can see my PowerPoint. Dr. Yudi Aryadi is an assistant lecturer at School of Mechanical, Aerospace and Automotive Engineering, Coventry University, UK. For educational background, he took his Bachelor of Engineering in Mechanical Engineering at Universitas Brawijaya, Indonesia. And his master research was done in Lancaster University, UK, followed by PhD in Design School, Loughborough University, UK. He has 11 years of experience in industry. We can see here, 5 years in product development of Isuzu Astra Motor in Indonesia, and 6 years in die design section head, Fuji Technica Indonesia. And I have here several of his latest publications. And his area of expertise are design and manufacturing. And also now he holds a position as Associate Fellow of Higher Education Academy in United Kingdom. Okay, Dr. Rudy. Oh yeah, he is with us now. Okay, good morning, Dr. Yudi.
Good morning.
Can you?
Assalamualaikum.
Yeah, it is still very early in UK.
Yeah, of course, yes. It's okay.
Okay, Dr. Yudi will present a paper titled Design for Sustainability. Dr. Yudi, you have 30 minutes to present your paper, and at the end of the session, we have a discussion for 30 minutes also. Dr. Yudi, please, time is yours.
Thank you. I'll try to My screen.
Iya, tapi nanti.
But I believe you can see my screen, full screen with the first page with the standard background or wallpaper given by the organizer.
Not
Oh,
yet.
no.
Dr. Ridi, we haven't seen your PowerPoint.
Okay. How about now?
Oh, it is now here.
Sorry, like confirm, is that still? Oh, I think I can see it. Right, okay. I assume the screen is all right now.
Yeah, it's fine.
All right, okay, yeah, thank you so much. Right, let me. Right, Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam
Good morning.
warahmatullahi wabarakatuh.
Good morning, everyone, and welcome to my presentation. First of all, let me thank you for inviting me to the organizer, and my deepest gratitude to Pak Dr. Agung Sugiarto, Sarjana Teknik Master of Engineering, as the chair committee of the committee, and Professor Dr. Sofyan Arif, Master of Science, as Rector of Universitas Muhammadiyah Surakarta, and Bapak Profesor Harun Joko Prayitno, Sarjana Ekonomi and Master in Humanity, and as representing the Rector of University Muhammadiyah Surakarta today, and all of audience for coming here today. As you can see clearly in my screen, the title is about design for sustainability, reflecting the idea, the topics of this conference about process and product design innovation towards responsible production and consumption. Let me start by saying a few words about my own background. I did my, as I've been informed by the moderator, I did my undergraduate at Universitas Brawijaya in mechanical engineering for more than 5 years actually. And after I finished my undergrad, I did work. I work at Isuzu Motor Indonesia for 5 years at product development, and 6 years after that, I work at PT Fuji Technica Indonesia as a design section head for designing tool press, press tool die design, basically the tools to create a car body panel from sheet metal. We're pressing it to become a shape for as a part of car body. And then after 11 years in automotive industry, I changed my career to academia, and I got a studentship at Lancaster University. To be exact, at Lancaster Product Development Unit. I work as a researcher there, working on 3D printing or additive manufacturing. Finished from them, I back to Indonesia and working as a lecturer as a Polytechnic Negeri Jakarta and Astra and Polytechnic Manufactur Astra for 1 year, and then I got another scholarship and for doing my PhD at Loughborough University in design school. Finished from that, during my PhD I work as a CAD tutor to helping final year student for doing computer aided design, and then I worked for 3 years at one of the research group. We call it Institute for Innovation for Sustainable Engineering at University of Derby for 3 years, and then 4 years I was doing postdoctoral research, working on design and develop a automated manufacture for turbine blade of Rolls-Royce. So it's fully funded by Rolls-Royce. And finished for that, I start my teaching career at Coventry University. I started as an assistant lecturer there. Next year, I'll be moving to another university, which is University of Warwick. Right. Next, it's about my outline of my presentation. My talk is particularly relevant to those who working on a product development or product design and manufacturing. And to reflect the idea of this conference, I would like to start with a very common approach with which I'm sure everyone here is very familiar. Thinking globally, acting locally. That's what you see on the screen. So basically, I will try to put something as reference to be global thinking and what we can do as a local acting. For the think global, I'll take SDGs, Sustainable Development Goals from United Nations, and as a local acting, I'm going to present about how to integrate sustainability into product design. I will not discuss too deep about the SDGs, but I will take some of them and then we discuss and embed into our product development process. There is 17 goals and 169 targets, but I think my talk is more or less will participate on around these 5 goals. The goals number 7, I simplified with the one keyword, let's say energy, and 8 and 9 goals number 9 will be about innovation. Goal number 11, I will say about transportation, although it says about the slum and dweller, but I think we can crystallize to a transportation, and the last one is about a greenhouse. Right, design process and sustainability. I'm going to use 2 approach and integrate them together, and then to use it as a tool during a design process. The first one is about engineering design process. There is different sources stated different steps of the engineering design process. There is some say 7, 5, 7, and some said up to 12, I think. But this time I took a 7, but they are more or less the same way of thinking as a tool to do the engineering design process. And the next tools that I'm going to integrate is using the life cycle assessment. Again, there is some other resources explain about 5 states or up to 9 states. But at the moment, I use the 6 stages, one from Brussels. It's stated in the one of the paper in Environment and Pollution Science at the Elsevier's journal. Right, we're going to into detail for the next slide. We usually use the engineering design process to approach our design as an engineers or as students, as you are involved. Most of you, I think, working with the students are supposed to use it when they do the assignment. For example, it's quite useful tools for them to solve the problem during their assignment or their final project. I use it in most of the time during my industrial experience. There are many different versions of the process, and the one that you see here, I took it from the teachengineering.org, and the 7th step of this design is start with ask to identify the need and constraint, and then the next one, research. What is the problem? And then step after that is imagine the possible solution, plan by selecting the promising solution, and improve and redesign as needed. And the life cycle assessment needs to be applied around about these 4 stages: ask, research, imagine, and plan. Ask, start sustainability into consideration at the very beginning. Research and imagine, where students or engineers start to design and expect them to always use the life cycle assessment in their design stages. Also, on the plan stage, when they select the best design option, they also use LCA or life cycle assessment as a tool to select. LCA approach I use in this presentation is adapted from the Elsevier journal or book, and it has 6 steps. Start with the resources for material extraction. So how the material extract from the, let's say, the earth, and material processing and how they processing the material from from the raw, and designing the component manufacturing and assembly, if any, distribution, and then product in use, end of life of the product, and start again from the very beginning. So the next slide, I will discuss into detail of every aspect of a design stage. The first one, resources. How the material is being extracted from the earth, how the consequences of the extraction. For example, the carbon footprint, carbon dioxide and other gases resulting from burning fossil fuels. How's the total energy, the non-renewable energy resources associated with the model's life cycle in units of megajoules, for example. Air acidification, burning fuel creates a sulfur dioxide, nitrous oxides, and other acidic air emissions. This causes an increase of acidity of the rainwater, which in turn acidifies lakes and soil. And how's water eutrophication occurs when overabundance of nutrients are added into a water ecosystem. And how is it being processed? For example, plastic can be in powder, flakes or pellets or metal can be angled or in seeds. sheet metal can be cut into sheet or in rolling and etc. There are a lot of things that we need as a designer or an engineer to think which one the best for environment. And the answer of these states is basically material selection. So there is a important state for an engineer or a designer or product designer to select the material. This is one of the example, let's say the most or the four top favorite material that usually people use. Still, 100% recyclable material. Some said it's permanent material, it's ambassador of circular economy. Aluminium, material that can be recycled indefinitely in theory. Of course, sometimes they need to clean it, the waste or the scrap inside can be reduced the character, the mechanical character of the aluminum. But I would say some said it's definitely you can recycle it. Plastic, the PET is one of the top, and the PLA as a biodegradable polymer material. And then the next one is a part for manufacturing. We use usually design for manufacturing as an approach. You need to select what type of the best manufacturing method that you need to use in order to produce the product that you design. For example, CNC is a very common example for part is best built by machinings, injection molding, where they need to think about the draft angle and consistency of the wall thickness. Stamping part, for example, the shape can be approached by the sheet geometry. It's strong, but need quite a big machine to produce that. And you also need to consider about design for manufacturing and assembly, because assembly process itself need very high energy and resources, need the task force, need the labor to assemble it. There is some approach recently that you probably familiar with what we call it 3D printing, or here I would say design for additive manufacturing. One of the example for this, this is the one case study from Autodesk and General Motor. This component is actually a part of safety belt inside the car. It has, I think, 8 components, and they try to use design for additive manufacturing approach to reduce the number of parts to become one part. As you can see here, there is a 15 iteration they need to do in order to find the best one. And finally, they managed to reduce the component from 8 into 1. That's what we call it the part consolidation. They use the approach, what we call it generative design, to make the shape like organic shape. And obviously, there is no other way to getting this product as using the additive manufacturing. They claim they managed to reduce the parts into one component, so there is no need for assembly. There is no assembly process involved to produce the product. And they say 40% lighter and 20% stronger. Imagine it's lighter but stronger. Lighter in component obviously will help to reduce the use of fuel. And the next one is the distribution. You probably just think, oh, distribution is about packaging. You may need to think about plastic using on the packaging or paper, which is biodegradable. But it's not only about packaging. It's also about what I would say stacking. I give you an example for example. Hello? Okay, I give you an example. For example, this chair is very beautiful. I know it's very classic, made by wood, but there is no way for you to pack it if you want to distribute it, unless except by just what we call arrange them like you can see on the screen. Comparing with this one, it looks modern, it looks simple. I know you will lose the unique or the classic shape of the beautiful of this chair, but as you can see, it's stackable, and you can see how many chair we can stack, and it can save the space and easy to transport. In, let's say, in one truck, you can bring more and more the chair on the right rather than the chair on the left. That will save again the fuel or transportation and footprint. Another example is for example, the plastic water bottle. You may think it's simple. It's just water inside a container. The shape of the bottle is just like that, as you can see here. But it's actually, if you can design it strong enough to make them can be stackable higher or better to save the space, you should do that. This is an example of the research done in International Research Journal of Engineering and Technology. They evaluate the buckling ability of the bottle, of the plastic bottle design, so that they can have more stacking water bottle than before. This will save again the distribution of food, reduce the distribution of footprint. And then next is product in use. So you may think about energy you use. For example, the less energy you use, the less battery you use, the better, or whether the product can be reused or it has to be disposable, or whether the product is easy to use. Easy to use product is also will keep the product usually longer than if something that not user friendly. Or you may also need to think about design for assembly or design for disassembly. One of my favorite example for this is the product from Icetia. Please bear in mind, I'm not promoting the Icetia, but the idea behind the Icetia is very interesting, where you can, it's good, inspired by this idea. For example, on this video, sorry. Yeah, this furniture, for example, they design not only for assemble by the labor in the production line, but they need to think, or as engineer, you need to think that this furniture can be built or can be assembled by general public, people without engineering background, just general people. So it is a challenge, because if you think that this product will be assembled, but in the production line, you may reduce the consideration to make it easy. However, Icetia make it easy for customer to do by themselves, or what term that you familiar with is DIY, or do it yourself. So apart from the concept of design, which is easy to assemble, is also good in packaging. So if you have experience to go to IKEA, they usually ask you to take your own product in box. So they are nicely collapsible, very small packets, comparing if it is a final product. And if you have seen the assembly instruction is also very easy, or even there is no language involved, purely just a picture and number. So it's eliminate the what we call language barrier, so everyone can read the assemble to build their product. So what's good in the product that can be, I think I have 5 minutes left. What's good the product to be assembled and disassembled is, as you can, I show you here is one of my favorite webpages from Facebook is Facebook Marketplace, where people can selling their furniture, and almost all of them are from IKEA. Why? Because IKEA can be dismantled. Other product is fixed. You cannot dismantle it. Imagine a wardrobe, a big drawer, for example, it will be difficult for them to sell, not only for them to sell, but for the people who wants to buy, they need a van in the UK, for example. Renting a van is very expensive. So this is an example where people can dismantle it and they can put, even for the small car, like a hatchback car or sedan or a small car, can bring all of this dismantled furniture if the furniture can be dismantled. So this is also good for environment, because people not throwing up the furniture, but they still can selling it to other people who needs cheap furniture or product. Right. Next one will be about the end use of product. I would say ask whether your product or your design product can be recycled. If not, okay, select material that can be degradable. This is an example. I think it's quite famous in Indonesia, where some of Indonesian invented the plastic made from singkong or cassava. So think about recycle. If you cannot think about the material that can be degradable, so although you need to throw it out to the landfill, but not damage the environment, they can be gradable or biodegradable. However, try to think before you throw it into landfill, before you recycle it, try to think to upgradable. This bicycle will be soon expired as this kid growing up. But this bicycle is designed to be growing with him. So instead of throwing up the bicycle that is already small for him, they can a little bit make a modification. Not modification, it's just change the configuration of the bicycle, and they can still use it a couple of years later. And yeah, that's all. The end of my presentation. Start from the taking or selecting the material up to the end of the product. Thank you very much.
Okay. Thank you very much, Dr. Yudi, for your interesting and comprehensive presentation. And I believe there must be a lot of questions from the audience, but sorry, you have to keep your question with yourself, because we have the discussion session after the speaker too. Here, let me greet Dr. Walid. Assalamualaikum, Dr. Walid.
Waalaikumsalam warahmatullahi wabarakatuh.
Okay, thank you. I hope you are good today. And now I will read your CV here. Hope I'm not struggling with the PPT. Okay. Full name is Professor Walid Fikri Faris. He is a professor at, Mechanical Engineering Department, College of Engineering, International Islamic University, Malaysia. And this is his extensive area of specialty. Yeah, very extensive. And for educational backgrounds, Professor Walid took both of his undergraduate and master degrees at Zagasik University, Egypt, and his PhD in nonlinear dynamics at Virginia Tech, USA. And here, a list of his professional affiliations. Actually, I have a complete CV of Professor Walid, but it's consisting so many pages, so I just made a brief, very brief summary here. Professor Walid has 63 international journals, 75 international conferences, 5 books, 8 edited books, and 2 patents. So Professor Walid will present a paper titled Investigation of Intelligent Suspension System. Dr. Walid, you have also 30 minutes to present your paper. So please, time is yours.
Okay, thank you very much. I will just try to prepare to share the PowerPoint.
Okay.
Okay, I hope everybody can see the presentation.
Yes, we can see that.
Okay. Bismillah ar-Rahman ar-Rahim. First, I would like to thank University Muhammadiyah actually for inviting me for this international conference. And it's a pleasure actually to join this great team of scholars and also keynote speakers in engineering area. One of the issues, of course, that is moving very fast in industry is the development of automotive industry. Automotive industry is considered a great platform actually for innovation, for design and development, and many other areas. And as far as I know, Indonesia has been having many of manufacturing facilities for automotive engineering with international companies. Many of the cars are assembled in Indonesia, and also there have been some activity on having a national car, as far as I understand. And at the same time also, automotive engineering is one of the key industries that can provide a large number of employment opportunities. Because usually, as many estimates, once you have one manufacturing facility for automotive engineering, you will need to have at least 150 to 200 feeding industry for this car manufacturer. So it's actually economic-wise, it's an interesting manufacturing activity that can help the country to grow and also help the country to have more employment opportunities for many people. So my discussion today on one of the issues that I have been publishing for a while on it, which is the intelligent suspension system of vehicles. To save time, of course, why suspension system is important? Definitely for any car, there are many criteria people looking at. And concerning the design of the car, concerning the facilities that are provided in cars, actually this is a very fierce competition among many car manufacturers. But the key issues that of interest to the consumer in the car design are the ride comfort and also the handling of the car. the ride comfort, and the handling of the car. So, and in general, these two objectives, a good handling and a good comfort, they are not going together. So there should be a kind of a compromise between having a good handling and also a good comfort. Suspension system plays a key role in the issue of ride comfort and also plays a key role in the handling issue. In this presentation, I'm just focusing on one of our research activity that we have published some time ago, related to having what people call intelligent suspension system, or sometimes people call it active suspension system. So all these names are the same, means using control systems in suspension. The performance of a suspension system usually is measured by several requirements. One of them is in fact, the vehicle, is the vehicle body acceleration in the three main degrees of freedom: heave, pitch, and roll. And also the suspension deflection. Suspension deflection having an impact on the comfort. And definitely the road handling, which is the tire deflection on the road. So these are some of the key issues that we can measure the suspension system with. Also, one of the measurements for ride quality, as I mentioned, is the heave and pitch and roll acceleration. And in dealing with the classical suspension system, though classical suspension system have been working and still working, and it is quite effective up till now, but of course, with the fierce competition among companies, people need to look for a more comfortable type of cars. So this is why there have been a switch into semi-active suspension and active suspension systems or intelligent systems in cars. Some of the car manufacturers are adopting this since some time, and there is an increase in the adoption of the active suspension system, especially with the advancement of electronics and other things. There's a lot of publication in this area, and still going a lot of publication. This is just a quick summary of this type of publications. And many control strategies have been used. One of the control strategy that we are using in this paper is what people call active disturbance rejection control, ADRC. It has been introduced by some people, especially by Gao and other authors, and Han also in 2001 and then 2009. And it is an attractive control alternative because it's easily applicable, and also robustness concerning this. So in our work, in fact, we have tried to do the following: to derive a nonlinear vehicle ride model for active suspension system, develop an active disturbance rejection control for active suspension system, and also coupling with it is input decoupling transformation. And to compare between ADRC standalone and ADRC with IDT. And looking into how to optimize the control parameters of the active suspension system and evaluating the performance based on this. The modeling of cars, in fact, have many approaches. One of the approaches is to have finite element modeling. Finite element modeling have been used, and it has some issues related to the complexity and also the amount of computation needed for finite element. Though some people are using it, definitely, but it needs a lot of computational facilities and also computational time, and need a bit of an expertise also in handling the finite element for such a big structure like a vehicle. On the other side, there have been what people call discrete modeling of vehicles. Discrete modeling of vehicles have been used since long time. One of the key issues or one of the attractive side of this discrete modeling is because it is simple and also we can use simple programs to solve or to simulate this type of models like MATLAB and other things. And we can also do a lot of variation. And we have proven in some of our publication almost 9 years ago that in fact the result coming from discrete models are quite reliable, and it can be a very good initial assessment before going into experimentation. And many other people also followed our suggestion related to this, that discrete modeling is quite useful. And as I mentioned, one of the attractive side of this is to have it simple and can be done with small facilities, not very large computation facility. When we look at these discrete models in the literature, majority of the discrete models in the literature, they are using linear approach. So in this work, we try to introduce nonlinearity in the vehicle ride so we can have a more accurate calculation, and in the same time also to assess is nonlinearity will affect the result much, or it will not affect the result much, and the linear system will be quite enough. So there are three types of nonlinearity usually in the vehicle model: the geometric nonlinearity and linearity due to suspension spring, and also nonlinearity due to the damper. This is the model that we suggested. I will not go into the details of the formulation, the mathematical formulation of this one. Of course, we can provide the paper, the details of the paper for those who are interested. The interesting thing about the result or some of the issues related to it is it can be observed that the linearized model is valid, especially for input height less than 0.152 meter, which is the maximum height for speed hump, according to the design guidelines from the Institute of Transportation of Engineers. So basically, linear models can work within a certain range. This is what we have proved, that linear models can work within a certain range. But if we exceed this range, then definitely we have to introduce the nonlinearity, because it will have an impact on the performance of the car. It will have an impact on the performance of the car. Also, one of the issues that we need to look at, is most of the works on active suspension system in literature were carried out with the assumption that the system can be reasonably well described by using a linear spring and damper model. Actual suspension spring and damper exhibit nonlinear behavior, which is the actual behavior of the car. And this, people has tried to prove this one several times, and have, as I mentioned here, many of the papers related on this one. This is also to show our result comparing between linear and nonlinear spring force for front spring, and also linear and nonlinear damping force for front damper as well. As we can see, and as I indicated earlier, that actually the linear model can work within a certain domain, but actually on the extreme side of this domain, the linear model will not work. So we have to introduce a nonlinear one. This is a description of the ADRC, which consists of two main loops. Also, because of the time, I will not go into detail, but this is very standard type of control strategy that people are using. And as I mentioned, one of the attractiveness for this ADRC system is the simplicity that we can do with it. I will just go, and this is also the idea of input decoupling, input decoupling transformation. How we do the decoupling between the heave and pitch and roll is explained in the formulation that in front of you currently. So in this case, if we add IDT to the ADRC, then we will have a much better observance of the parameters in the control system. Let me go to the result related to this one. This is the response of to speed hump, and we can see the passive suspension system and the ADRC if we introduce ADRC as a controller, and if we introduce ADRC with IDT as a controller. So basically, if we look at this result, we will find that actually having ADRC with IDT is giving a better performance, especially in the steady state case, and also will bring the system to a more stable case quickly than having ADRC or having also the passive suspension system. These also some of the measures comparing the ADRC and ADRC IDT for heave and pitch and roll acceleration, how having the decoupling transformation will have a better reduction in the vertical and pitch acceleration. The same goes also for the maximum control force needed, and the same goes also for the reduction of the tire deflection that we have. The only thing that might look a bit more interesting is the percentage reduction for suspension deflection. The negative value indicates percentage increase. So this is the only thing that comparing ADRC and ADRC IDD will have a kind of we cannot say questionable, but interesting result that need further actually investigation. We have also introduced instead of the hump, which is usually the regular hump is the classical description for a road. We have introduced also excitation from a ground, which is more realistic by having a random function. There is a standard actually for introducing a random surface elevation profiles or road profiles. And this is one of the classical one that is used by many literature related to the road. And the result is still the same. In fact, the result, when we look at the result, we will have that still ADRC IDT, ADRC with the decoupling transformation is still better performance than only ADRC. So in conclusion, introducing the control system basically will have definitely better performance than the passive system. This is actually no doubt on this matter. Now, all the literature on the intelligent suspension system would agree on this part. The issue is among different suspension system is or different control strategy, which one is more robust, which one is easier to implement, and which one is easier to be understood also as well, because there are many controllers that are quite difficult for people working in industry to implement or even to understand. So this makes ADRC a kind of one of the good options. So introducing ADRC only will have a better ride performance and high control effort. And if we have the decoupling added to the ADRC, then we'll have a better trade-off. So lower control effort, which is a key issue, and also more robust to change in input disturbances. This is simply the conclusion for this paper. As I mentioned, there's a lot of details in the paper related to the formulation and other things, because most of the this work is mathematical, based on the formulation and other things. So with this, these are some of the references related to the matter. And as I mentioned, our group have published considerably on this topic, and you can actually check our publication on this matter of active suspension system, and also active engine mount system that we also published a lot on this matter. I tried to keep the time. I hope I finished on time or a little bit before time. So if you have any question or have anything, please proceed. Thank you very much for your attention and for listening. I appreciate it.
Okay, thank you very much, Professor Walid. It is such a great topic and presentation. Okay, ladies and gentlemen. Sorry, I just here. Okay, ladies and gentlemen, we start the discussion session now regarding to the speaker's papers. You can click raise hand icon and start your question. Please mention to whom your question is directed to. So let us begin by 3 questions. Any question from the audience? We have 30 minutes here. Okay, 1 question from Taurista.
Okay. Can you hear my voice?
I think it's a lot of noise. Yeah, it's echoing.
Hello?
Hello?
Now, okay?
Yes. Yeah, it's better now, much better.
Okay. My name is Taurista. I'm from UMS. I have a question from the speaker 1. In your presentation, you mentioned the concept of 3R, the reduce, reuse, and recycle in manufacturing. So is there any order for this 3, or is it arbitrary according to the needs? I hope that my question is enough to you to understand the question. Thank you.
Okay, thank you, Dr. Taurista. And the question is for Dr. Yudi, right? Okay, Dr. Yudi, would you please answer the question?
Yes, I can clearly hear, but I'm not really sure I get the answer. The question about reuse, recycle.
Yes. Is there any? Let me re-explain the question. Is there any order for the reduce, recycle, and reuse, or it's just arbitrary? I mean, can we start at one point, or, for example, we have to do the reduce first or the recycle first? Is there any order for that, or it's just arbitrary? Yeah, thanks.
Thank you for clarifying that, Bu. The most important is the answer is how big it will impact the environment. So based on that approach, how big its impact to the environment, including the energy you're going to use, I think reuse is the best. So try to use the one that the lowest impact to the environment. I would say like reuse means you don't have to do anything with your product. For example, one of the presentation is about the bicycle. So you can straight away reuse it without too much energy or effort to modify it. If you cannot it, then you will let do recycle. So select something with the material can be recycled. Recycle, why I said a second choice rather than reuse, because recycle still need a lot of process in it, a lot of energy, and you sometimes need a chemical to make it clean, etc. If you cannot recycle it, then I will let you select, not I will let you, then we will going to select the one that we cannot avoid it, where we need to throw the unused product or the end of life product to the landfill. But again, there is a consideration, please, if you use something that you need to throwing up to the landfill, please use the one that not damaging the environment, which is something like biodegradable or degradable one. I think hopefully it's answered the question. Thank you.
Okay, thank you, Dr. Yuti, for your answer. So the main thing is not damaging the environment.
Yes. Yeah,
Yeah.
right. Yeah.
Yeah, so 3R also has some tricks to implement them, right? In the process and product design. Yeah,
Recording
thank you.
stopped.
And Dr. Tarisa, is there any sequence, any other question?
No, thank you. I think it's a good answer, and it's our duty to keep our product to be environmental friendly.
Okay, thank you. So we move to the next question. Is there any
Recording
other
in
question?
progress.
Is there any other question from the audience? We are still waiting for the next question. Okay, while waiting, can I just have a question to Dr. Yuti? Okay.
Yes.
Yeah, thank you. You just mentioned the main target of life cycle analysis, but I think I still didn't get it along. So my question is, what is the main target of life cycle analysis? I mean, in process design, you mentioned, is it zero waste or product quality? Because in some cases that I experienced, we have to sacrifice one thing between those two. Thank you.
Well, it's a very good question. Usually, if we say very good question, it's difficult to answer. What I mean by that, it really depends on the the business itself. So I would say, if your company or your business can allow something that not really environmentally friendly, you would also do that. Because, for example, you can sacrifice, zero waste, but you need to sacrifice a lot of energy, a lot of investment, for example. If you can do that, that's fine, please do. But the target, of course, is zero waste, zero carbon, and many other things, you can name it. But again, it's then belong to the company policy, whether you can achieve that or not. But obviously, it will also rely on the country that you live in. Sometimes you cannot say no. You have to do zero waste or to reduce everything you can do. Otherwise, you will not allow be operating the company. In this case, I would say start from the business. You can think, you can see, you can calculate whether I can achieve that or not. Yeah, sorry, maybe I cannot answer straight away, but for sure, it's rely on the company whether you can achieve that or not. Thank you.
Okay, thank you very much for your thorough answer. Okay, back to the audience. Is there any question? Still any question? We still have plenty of time here. Still there is no question? Or maybe Dr. Yudi, regarding to zero waste, I think what factors should be considered in product or process design to reach the zero waste? As you know, as I am from chemical engineering in this case, keeping the environment safe is one of the major goal of chemical engineering.
But chemical is actually not my area, but we start usually with the risk assessment. So apart from the approach that I explained to you about engineering design process and the life cycle assessment, we also do what we call risk assessment, and in manufacturing standard we call it design failure method. So to see what is the failure of the product. It starts from the defect that you're going to get up to the waste that you're going to produce. So we need to work in detail how it will impact to the environment for the waste that you produce. So yeah, I would say we need to do the risk assessment process or design for failure mode manufacturing method, or the FMA that we call it. Yeah.
Yeah, thank you. So we cannot skip the risk assessment.
No, yeah, of course, yes. Especially for if you need to comply a standard, let's say, I would say, for example, ISO in automotive or QS also in the automotive. And if you need to complete that, you need to fill all of the risk assessment, including the one that will affect to the environment. I used to work also in Rolls-Royce, but Rolls-Royce is not automotive, in aviation. They have their own standard, then it's always contains about the risk assessment, including health and safety and environment. Yeah.
Okay, thank you, Dr. Yudi, for your answer. I come back to the audience. Is there any question? Still no question from the audience? Or maybe, Pak Agung, do you have any question? Okay, I will fill the time to Professor Walid. I have a question for you while we are waiting from the audience. You mentioned the passive and active suspension in your presentation. Yeah, basically the active suspension. Yeah. I want to know what are the advantages of both if we compare them. Yeah, because Dr. Yudi explained the passive suspension in his presentation, while you mentioned the active suspension. Yeah, is that right? So I want to know what are the advantages if we compare them in this case. Thank you.
Thank you for the question. In fact, of course, passive suspension, as I mentioned, is the most commonly used up till now. And why people are using it? Because it's cheap. And at the same time, also, people know how to do it, how to manufacture it. And it works well for most of the application. But as I mentioned, the competition between car manufacturers is basically on ride comfort and on also better handling. And both of these will need much better control, in fact. So this is why the issue of active suspension system have been introduced. And it also has been commercialized. So many cars now, like Mercedes, BMW, usually the bit of an expensive cars, they are implementing active suspension system. So active suspension system will provide a much more better ride quality and also will help to provide a better handling on the road, especially for those who are traveling long distances. People might not feel the difference if they are using a car within the city. Why? Because using the car within the city usually is a small type of distances and people cannot feel the impact of the ride quality. But if you are traveling in bigger countries, like definitely like Indonesia, United States, Canada, most of the also European countries, people used to travel long distances. So ride quality is very essential here. And the active suspension system will provide definitely a better quality. This is clear. This is very have been proven since some time. Yeah.
Okay, thank you, Professor Walid. So basically, this is about the application. Yeah, active suspension is more applicable, and it has progress. Yeah, some progress compared to the passive one. So I will check first. Oh, still there is no question from the audience. So for both speakers, maybe regarding to zero waste in product or process design. Actually, this is a question from the audience, but it is sent to me privately. So I will read the question here to both of the speakers. Yeah, which one is more important, easy assembling or easy to deassembling in one product? Maybe Dr. Yudi can answer the question first.
Oh, yes, I think it's both. If the question is regarding to my example of the product, it should be both. Because usually you just only design a product to be assembled. And then the next one to be assembled by general public atau orang awam or people without any engineering background of skills, engineering skills. So to be assembled by production line, to be assembled by general public, it's a bit more challenging. And then to be disassembled, that's why I put clearly design for disassemble. Means you need to think that this design can be disassembled easily. Why I need that? Because as I said, reuse is the best option. If you don't use your furniture, why don't you just selling to someone else that they still can use it? If you're selling the furniture as it is, as big as it is, it will be difficult, especially for example in the country like in the UK, renting a van, it's sometimes more expensive than the furniture I bought. To be honest, it's my own experience where I have a small car, but I can bring or even the king size bed of Icetia inside my car. Because of what? Because they can be disassembled. So both assemble and disassemble, they are important. Because other than that, other than about the furniture, for example, in automotive, if you can easily dismantle, it means you can easily maintaining it. So yeah, that's my answer. Thank you.
Yeah, thank you, Dr. Yudi. And how about you, Professor Walid? Do you agree or do you have any other opinion or maybe a priority between those two, easy to assemble or easy to deassemble?
Actually, in design, this is also have been long time back. People talk about design for manufacturability, design for maintainability, design for reliability. So we have actually added on the design process many aspects, criteria that we need to look at. Concerning assembly and disassembly, it depends on the product. Some products are considered not for the public to handle it. So this is why usually the assembly and disassembly will be done by professionals rather than done by the consumer directly. But if we look at furniture, for example, or if we look at things like bikes, things that people are using, definitely having an easier assembly and disassembly will be a marketing edge for the product. And at the end of the day, in engineering, anything in engineering, we look at the economy. So whatever you do, you want to sell. And whatever you want to sell, you want to satisfy the customer. So if we have an easily assembled and disassembled product, usually people will buy it more than a complicated one. But as I mentioned, some cases is not actually for public to handle it. Like, for example, you will not have an airplane to be handled by the consumer directly. It should be handled by professional bodies or something like this. Also, some cars will be handled by professionals. The only thing, as Dr. Yudi mentioned, is basically not disassemble, but actually maintainability. So we need to have a good maintainability, the design for maintainability. If I have a car which is very complicated that no mechanic can do it properly, then nobody will buy this car at the end of the day. People will buy a car that they can send it to any mechanic, any professional mechanic who can maintain it easily for them. So this issue has been, in fact, a very interesting topic in design for a while now. And as I mentioned, what the main criteria is, can you sell your product and consumers will be satisfied or not? This is the bottom line of the whole thing. We design for people, we design for consumers. Thank you.
Okay, thank you very much, Professor Walid, for your answer. Yeah, for a great answer. Okay, I will check again.
Bu, sebentar Bu,
Yes.
boleh saya tambahkan? Oh, sorry,
sure,
can I add something? Yeah,
Sure.
thank you very much. Professor Walid reminds me that yes, not every product can be a fit with the concept of assembly and disassemble. I think one of that, I think it's important to mention as well, sometimes the company need to protect the product. It's not because of the need to protect, but it's because of the safety factor. If they let customer do it themselves, it can be dangerous, for example. It can be, dangerous. It's not good for health and safety. That's why sometimes they protect the product not to be dismantled by the customer. Although this is not what we call, I don't have any validity for this, but some articles saying sometimes they protect because of the business. For example, in printer, they deliberately protect the way the printer counting the ink until or what they call it, design obsolescence. Jadi, so they deliberately make the printer not working up to a certain printing. So yeah, sometimes the protect. One of the recent example is the iPhone. Start from the iPhone 12, you can easily changing the battery. Before that, the battery, they just gluing it. So it's really difficult if the iPhone the battery starting to die, where we can easily replacing the battery, where the previous product, maybe some of you experience where the battery can really replaceable, but at today it's not, and it needs a professional. I don't know, there is a business reason to do that, but obviously there is one reason, safety, to protect the product, not to be dismantled. Thank you.
Okay, thank you, Dr. Yudi. Professor Walid, is there any addition from you?
No, thank you.
Okay, thank you. Maybe the last question here is Professor Walid. Another question from me, but this is a very common question. Yeah, I'm sorry. What do you think? What is the greatest challenge? Yeah, putting innovation or integrate innovation into the existing process. Yeah, sometimes we have a process. Yeah, to produce something that existed for decades, maybe decades or so many years. And we have a new innovation that will help the process. But I believe in integrating the innovation here, it takes a lot of efforts. So what do you think? What is the greatest challenge in this case? Thank you.
In fact, this question can lead to another lecture. It will take a long time to explain. But what we need to understand is we do have two types of innovation. One type is what people call disruptive innovation. Disruptive innovation means I will make a drastic change in the product. And this drastic change will lead to changing the production line and lead to major changes in the process itself. This one is, of course, is not easy to be integrated, and it has its own way to be handled. But on the other side, there is the innovation, which is actually the Japanese school introduced. In fact, and many of the Asian countries like Korea, like also China, they have been following this one, which is a systematic small innovation on the current product. So I have a certain product, so I will make a kind of better systematic innovation without disrupting the whole process. This one will take time, but it will improve the product at the end, and it will lead to a kind of a perfect, of course there's nothing perfect, but to a level of perfection, So integrating this systematic small innovation to a product is easily to be integrated in the process, because this will not need to have drastic changes in the production line, in the production process, and all of this, or to introduce certain new skills to the people, the workers who are doing the production or the design. But the disruptive innovation, which has been common currently also in many Western countries, especially in the United States, this one is not easy actually to be integrated in the system. It needs a lot of, it needs an organization which is have been used to such type.
Okay, thank you very much, Dr. Walid. Since we don't have Any question? Yeah, from the audience. So I think now we have reached the end of this session. Yeah. So as an appreciation, we have prepared certificates for both of the speakers. Committee, would you please display the certificates on screen? Any difficulties here? Okay, yeah, so this is the certificate for Dr. Yudi as an appreciation from the committee. And the next one is the certificate for Professor Walid. Yeah, thank you very much for your great presentation in this case.
Thank you very much for this invitation, and thank you for the great moderation also as well. You have done a great job. Thank you very much.
Thank you very much. Basically, I'm afraid if I give such common question because I'm from chemical engineering. Okay, so on behalf of the university, of the committee, and also from myself, I express my gratitude to both of you. In coming years, we hope this relation shall be continued. Thank you very much and have a great future. Wassalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam.
Thank you to Dr. Akida Mulyaningtyas ST MSc, have lead for first panel session, and thank you to our speaker Dr. Yudi Aryadi and Professor Dr. Walid Fakri Faris for the new knowledge and experience.
The next session, there will be announcement for the best paper of Icetia and Rapi 2022. The best paper of Icetia, there will be two nominations. First is best paper from student, and the second is from general public. I will read from the student first. The third winner is Arif Bayu Priyambodo, Sri Sumarjono, Senja Rum Harnaini, and Zilhardi Idris. Okay, the third winner is Arif Bayu Priyambodo, Sri Sunarjono, Senja Rum Harnaini, and Zilhardi Idris under the title Mechanism for Proposing Kabupaten Road Damage Improvement Program Using Krishna Application.
Congratulations for the winner.
The second winner is Hashim Ashari, Abdul Basit, and Tasya Fadila under the title Design of an DC Generator Monitor System in Real Time on Internet of Things Based Static Bikes. And the champion is Dia Widi Astuti and Kusudiarsana under the title Reinventing Cultural Tourism of Kamlayan Broaden, meaning increases sustainability. And the second nomination is from general public. The third winner is by Imron Roshadi, Suyitno, Zainal Arifin, and Tata Suryadi under the title A Simple Method for Increasing the SI and Aluminum Ratio in Natural Zeolite, a morphology and crystallinity study. The second winner is by Hanif Nada Syahputra, Senot Sanyaji, and Halwan Alfisa Saifullah under the title Seismic Fragility of High Voltage Transmission Tower Due to Earthquake by Using Adaptive Pushover Method. And the champion of Icetia from general public is Aulia Rahman, Kristanti Dewi Paramita, and Paramita Atmo Diwirjo under the title Rewilding Design, Architecture by Nature. Congratulations for the winner.
And the next announcement is for the best article of Rapi. There will be several categories. I'll read. The first category is for the article that relevant with the theme. The 2N winner is written by Lucy Indriani and Agung Sugiarto with the title Pengaruh Durasi Waktu Aerasi Pengolahan Air Limbah dengan Sistem Lumpur Aktif atau Bioflokulasi terhadap penurunan BOD atau Biological Oxygen Demand Air Limbah Rumah Sakit PKU Muhammadiyah Surakarta. And the first winner is written by Kun Harisma, Ananda Muhammad Batistuta Kaparias, Ahmad Muhammad Fuadi, Tri Widayatno with the title Inovasi Biopestisida Alami dari Tembakau atau Nicotiana tobacum, bawang putih atau Allium sativum, dan daun pangi atau Pangium edule. The second category is for the best innovation article. The 2N winner is written by Taufik Aris Ismail dan Umi Fadila with the title Pestisida Cair Otomatis Berbasis Arduino Nano. And the first winner is written by Ratnasari Nur Rohma, Nurhuda Fauzi Rahman, Bambang Haripe, Nurokim with the title Pengembangan Sensor Kelembaban Tanah Nirkabel untuk Keperluan Irigasi Pertanian Otomatis. And the last category is for the best writing article. The 2N winner is written by Muhammad Ridwan Abdi Harits Pratama with the title Pengaruh Ketebalan dan Jenis Material 3D Printed Core terhadap Kekawan Bending Composite Sandwich Skin Serat Karbon. And the first winner is writing by Atarika Azaka Farnida Mukhlison Anis with the title Perbaikan Postur Kerja Pekerja Menggunakan Metode Workplace Ergonomic Risk Assessment atau WERA dan Evaluation del Riesgo atau ERIN dengan studi kasus PT2 Admi Muda. Congratulations for all the winners. Ladies and gentlemen, we will continue to the next agenda. We continue to the panel session 2. We'll be guided by our moderator, Mr. Eko Setiawan, ST.MT PhD. He is our senior lecturer in the Department of Industrial Engineering, Universitas Muhammadiyah Surakarta. I immediately handed over to Mr. Eko Setiawan to guide panel session 2.
Hello, check. Okay, thank you very much, Mira Septikahwati and Muhammad Arhab At-Torik. My dear fellow researchers, practitioners, academicians, and all participants, Assalamualaikum warahmatullahi wabarakatuh. And good morning for everybody. So we have come to the panel session 2, And in this session, like previous one, we have two speakers. The first speaker is Associate Professor Muhammad Mujibur Rahman, and then for the next speaker, it is Dr. Fatwa Firdaus Abdi. This session will be carried out by firstly all participants listen to what Bapak Muhammad Mujibur Rahman present, and before we proceed further, please allow me to present his short curriculum vitae. So, Associate Professor Muhammad Mujibur Rahman, PhD. His full name is Muhammad Mujibur Rahman. Apologize for that. And his current position is Associate Professor, Department of Chemical Engineering, Faculty of Engineering, Universitas Muhammadiyah Surakarta. He got his undergraduate degree from Chemical Engineering Department, Universitas Gadjah Mada, UGM, spending from 1992 until 1998. And then from the same department, he obtained master's degree, which was from 2001 until 2003. And then at University of Waterloo, specifically at the Department of Chemical Engineering, he got a doctoral degree. Associate Professor Muhammad Mujibur Rahman has area of expertise in separation technology, distillation absorption, membrane technology, transport phenomena, modeling membership, and modeling. And then he also has membership of professional societies in ACS, and still in process. He is also applying for a member in Persatuan Insinyur Indonesia or PII. His research experiences span from utilization of rice husk as microparticles as a filler for ceramic titles to cytosan speak composite membrane for methanol fuel cells and acid hydrolysis of wastewater paper using microwave heating as a raw material for making bioethanol, preceded by a detoxification process to enhance distillation of azeotropic solution using fixed absorptive distillation, as well as the colorization of coconut sugar solution by absorption. He has so many publications, including so many papers, as well as patents and copyright. For papers, to mention some of them, is effect of temperature, concentration, and type of plasticizer on edible pectin film characteristics of mango peel or Mangifera indica L, published in Journal of Chemica in 2022, and the influence of activator type and temperature activation on the specific surface of corn cob waste absorbent, published in Journal of Physics Conference Series in 2021, and so many more papers, starting from a preliminary study, distillation of isopropanol water mixture using fixed absorptive distillation method, published in Journal of Separation and Purification Technology in 2006. He also has several books as well as book chapters as follows: Process Equipment Design, released by Muhammadiyah University Press in 2022, Computational Modeling of Pervaporation Process, in the book Polymer Nanocomposite Membranes for Pervaporation, apologize for that, published by Elsevier in 2020, until Thermodynamics 1. Of course, the last one is published at his starting career as a lecturer. He also has patents and copyright, including emergency oxygen concentrator, vacuum gate sterilizer, and modification of concave membrane-based hemodialysis machine for cholesterol separation. That's all about short CV of Associate Professor Muhammad Mujibur Rahman. My dear Professor Muhammad Mujibur Rahman, can you hear me?
Yes, Mr. Eko.
Okay,
yes.
So for this first part of this session, we will listen to Associate Professor Muhammad Mujibur Rahman, who will present his paper entitled Optimization, the Key Concept in the Equipment, Process and Product Design. Dr. Mujibur Rahman, you have around 30 minutes starting from now. Time is yours. Thank you.
Thank you very much, Dr. Eko. Assalamualaikum warahmatullahi wabarakatuh. First, let me show my presentation slide. Okay, I'll be okay. Thank you very much, Honorable the Vice Rector, Professor Harun, and maybe Rector, I'm not sure, yeah, Prof. Anif, and then Honorable the Dean of Faculty of Engineering, Dr. Rois, and my colleague from elementary school, and then Honorable the Chief of Committee, Pak Dr. Agung, and also Honorable all the committee members of Icetia 2022, and also Honorable all the keynote speakers, and also Honorable all the participants in this conference. Thank you very much for giving me an opportunity to share some ideas related to this topic conference. Actually, I'm now I'm one of faculty members in Chemical Engineering Department, Universitas Muhammadiyah Surakarta, and my field of interest are, as mentioned by Dr. Eko, related to aspiration technology, and then especially distillation, adsorption, membrane aspiration. I also concerned with membrane transfer phenomena, and also modeling, and also thermodynamics. But at this occasion, I will not talk about my specific area of my research. It is a little bit general idea because of the divergent audiences, not only from chemical engineering. I talk about optimization. I think everyone agrees that optimization has a significant role in the area of design of equipment and then process and product. And the outline of my presentation will be, I start with background, like introduction, and then concept of optimization is like refreshment or review from the material that we have studied, high school, higher school, university, and then some examples, some cases, optimization in design of equipment, process and product, and I close with conclusions. I will, yeah. Okay. So yeah, we know that technology is developed by mankind to improve well-being of life in terms of in the forms of like ease and speed to work, and then comfort level, cost efficiency, energy efficiency, productivity level, and etc. And the technology development can include the development of equipment, development of process, and product development. In the design of equipment, for example, actually there are some levels of purposes, some levels. Actually, the very simplest design in equipment is to predict the cost or the price of equipment, and the design of equipment itself is actually done by other parties, not us. We just predict the cost, and I didn't write here. And the second level, first level here is designing the equipment that can work well as it functions. And then the second level, higher quality than the first one, is to design the equipment that not only can work well, but also most economical. And then the last one is we design the equipment that functionally can work well, and then most economical, and also ready to be installed in the plant. We can have illustration here. For example, when we design a water dipper, gayung air, the function is to like take or to dip 1 liter of water. Any dimension can be designed actually to do the function, but of course we have question which dimension that give the most economical. Yeah, this is the like here diameter and height. The height is larger than 1, the diameter, and it's like diameter relatively same with the height, and then this is the height is less than the diameter. And then we have another illustration, like in the process of distillation. First of all, we want to purify multi-components in the feed, in the solution, in which we cannot spirit by decanting, by filtration. These solutions, homogeneous phase, we want to spirit. For example, we have 3 components here. There are 2 options of sequencing by distillation. The first option, we spirit A first, and then B and C, and the other, like in B, we spirit first C, and then A and B. Which one is more economical? Or in other design product, like design product, and here I just give illustration, like design product actually related to end user of customer. For example, we want to produce a chair, we want to produce table, which one is more comfortable, which one ergonomic is good, and etc. But in principle, all these things actually, we need optimization. To design the optimum equipment, process, and product, we need optimization procedure. A little bit go back to the refreshment theoretical point of view of the optimization. I took from one of reference, but it is not official reference. Medium, yeah, from the internet. Yeah, optimization is like an act, process, or methodology of making something. Can be design, system, or decision as fully perfect and functional or effective as possible. The substance is actually the same what I have mentioned at the beginning. And in optimization, there are 2 types of optimization. The first one is minimization, and the second one, maximization. There is no 10 point, minimum point, maximum point, is 10 point, there is no 10 point. Minimization actually relates to some things that are detrimental, hazardous, dangerous, cost, expense, or in general negative impact. How to minimize these things. And then maximization relates to things that are profitable or positive impact. And if we want to solve optimization, we need to design equation, the objective function, the one that want to be optimized. And then in theory, we have two types of objective function based on the affecting variables, the variables that affect the dependent variables. It can be single variable, it can be multi-variable. And here in one single variable, it can be unimodal. Unimodal means in all the function, in all the curve, there is only one optimum point. And the function may have global optimum as well as local optimum, like illustrated here. Global maximum, global minimum means the point that apply the highest, if it is maximum, the highest for all the range that we observe. And then local mean, yeah, it is maximum or minimum point, but not the highest and not the lowest one. And multivariable, similarly with the single variable, the only thing is that the number of variables that affect the dependent more than one variable. And then how to solve any problems related to equipment, to process, to project. Actually, they follow similar procedure, similar steps. The first one is, of course, we must derive the equation to be optimized. And then once how to derive, we can use mathematical theory. We can use like in chemical, we use chemical engineering tools, or we can use even empirical equation, just matching the data between the dependent and independent variables. And then how to solve the problem in optimization. In general, we have three types of solution, like graphical, the simplest one, and then analytical method and numerical method. Like here in this illustration, by graphical, and this is very simple, only one variable, and also unimodal, only one optimum point. We see that this is the minimum point here. And then using analytical method, actually we can use concept of differentiation, differential equation. It is believed that it is mathematically proven in theory mathematics that at optimum point, the first differentiation will be 1. But for single variable or multivariable, if it is multivariable, then we differentiate each variable, partial differentiation. For example, if we have x1, x2, then when we differentiate x1, that means we consider the other x are constants. And then from mathematics theory, we know that at maximum point, that's means the second differentiation will be negative, and then minimum point means the second differentiation will be positive, and then third point means titik belok, the second differentiation will be 0. And we have example here that this quadratic equation actually follow this equation, x squared minus 6x and then plus 8. And from the graph, we know that the x optimum is 3, and then the y minimum, the minimum point is -1. And we can prove here the first differentiation equals to 0. We have 2x equal to 6, then we have x equal to 3, the same. And then we put 3 into the equation, we will have -1 here. And it is also proven here that when we build up empirical equation based on from experimental data, we can use trend line in Excel, and we know exactly this is R equal to 1, because it's actually quadratic equation of this one, perfect equation. Actually, we know that empirical equation is good when R squared approaches to 1, and we must note that not only approach to 1 or equal to 1, but the line of equation must also follow the data smoothly, not just following the data points, but it is not smooth. Because if it is not smooth, then it often we fail to predict the value outside the data range that we observe here. And then numerical method, I will not talk in detail. We know single variable, there is golden section, and a new method, Newton, and then multivariable, we have steepest, ascending, descending, and then hook chief, and etc. Like here in numerical, actually, numerical is just approach method. The result is not very exact like in analytical methods, but approach method is very useful when the equation is very complex. It is just simple iteration of calculation, but it is also not difficult, even though done repeated many times, but it will be solved by computer, by programming. And this is the illustration by using golden section, the simple approach. Yeah. For example, we have, this is the point, the maximum point that we want to know, and we start from trial between 2 points, and then we put other points inside there, and then we compare the value of y or function x, and which one is less will be eliminated, and there is specific value of interval variability. I will not talk in detail about this because everyone already also studied about that. And I just go directly to the in practice, like equipment design. When we want to optimize related to design of equipment, that is in second level or third level, that the equipment can work as it function, and also the production cost or maybe annual cost, including the operating cost, should be the minimum one. For example, here when we design a liquid storage tank in the plant, so actually the total annual cost mainly affected by the fabrication cost of the equipment, including, we symbolize here C1 to C5, that actually annual cost of fabricating cell, and the unit is cost per area until 5, and the 5 is land for land. The place to put the tank, we need land, and then foundation, we need civil engineering also to put the tank in the plant, roof and etc. And from the unit here, we can formulate the objective function, C, total annual cost, just multiply with each area. And the area here, the cell is clear, this cell cylinder area, VDH, and then for other, we consider the same area, it is circle. Actually, the different roof a little bit different, but we make approach that roof and bottom and also land and foundation has the same area. It is circle area. And then, we continue again to continue with this equation. We simplify, blah, blah, blah. We know that, this objective function, initially, it is multivariable. It has 2 variables here, but we can simplify, become 1 variable. We can correlate D in each with the volume of tank. Usually, tank has a certain purpose to contain a certain volume of liquid, and from the liquid volume, which is fixed by process, we usually make over design like 20%. Then from that, we can design, we can know from the volume of tank. And then the volume of tank become not variable, it become fixed value. Then we can express H in terms of D, or D in terms of H. In here, we choose, we express H in terms of D. Then finally, we have objective function, only one variable, it is affected by diameter. And then we do solving optimization using analytical method. We differentiate there. First differentiation of C as function of D here become something like this. And finally, we have this one, D equals to TH, blah, blah, blah. And this is actually for a small tank. In the plan, the small tank, one of category is, the diameter is less than 45 feet or maximum 45 feet. And then for large tank, actually, it's similar equation here, D, blah, 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 for its. And this is cost index, this depends on cost production, depends on the environment, the location that the plant is built. For example, here from the equation that we have, the cost for fabrication cell for small tank, and then roof and bottom is usually we consider the same, and then land and foundation, and then we ignore. Actually, there is some, but it's very low compared to 1, 2, 1, C2, C3, and C1. Then we can ignore here. And then finally, we have, I can see maybe, I mean, sorry. Yeah, we can ratio. Usually for small tank, we have ratio D per H optimal about 1. And then for large tank, we have D per H optimum. That means the one that gives minimum annual cost, it is about 8/3. So that's why in the plan we usually find this is the typical tank in the for small tank. Yeah, the diameter is similar to the height, and this one for large tank, the diameter is higher, yeah, much higher than the height. Then I prefer to use another example in chemical engineering. For example, in distillation column, we also have case of optimization, especially in cascade distillation. Cascade distillation means in the column of distillation, there are more than one stage. This stage actually is like a device to facilitate contactness between liquid and vapor. And then reflux ratio, it will affect the number of stages here. Increasing the reflux ratio means the ratio between the flow that which is returned back to the column compared to the product taken in the distillate. Increasing reflux ratio will decrease the number of stages here. Of course, for given combustion of product. In other words, decreasing reflux ratio will increase the number of stages here. So if the number of stages decrease, that means we have a lower height of column, and the cost, the price for column will be cheaper. But if we operate lower reflux ratio, then the number of stages will increase, and that will increase the cost for the price for the equipment. In other side, when we increase reflux ratio, that means more liquid return back to the column. That means the duty for condensation and for vaporization in the reboiler also higher. That will increase the cost for operating cost in the distillation. So the typical total cost to operate distillation column is as illustrated here in the figure. So actually, so I want to remove again the, okay, that's one. Reflux ratio, X here, increasing reflux ratio will decrease the number of stages. So that's why the cost for column is decreased. But increasing reflux ratio increasing reflux ratio will increase the duty for heating and cooling. So the cost for operation also increase. And then the total cost actually just combination between fixed cost and heating and cooling costs. Here we have this one, the curve in the top here, and there is optimum point here. This is the optimum reflux ratio that we use in plant usually in distillation, and by Carlson and Richardson, they actually these people collect many data in the plant for distillation, and the range for operating reflux ratio is about 1.2 to 1.5 times reflux minimum. And then this is another example how to optimize the reflux ratio. We can also actually make a graph correlation between number of stages and reflux ratio here. Remember, increasing reflux ratio, decreasing the number of stages. And we know that in the beginning of starting up here of plant, usually we operate distillation at total reflux. Total reflux means all the distillate, all the top product is returned back to the column. There is no distillate taken. That means L per D, D is 0. That's mean the total reflux is the infinite number here. And the number of stages that we have, actually we call minimum stages here. In reverse, if we operate at minimum reflux doesn't mean that L0, no. Minimum reflux, there is amount also, not like reflux total. And if we operate at minimum reflux, that means the number of stages here is infinite number. So we operate between minimum reflux and total reflux. And based on this graph, the optimum point actually, the optimum reflux ratio is the closest distance with the central coordinate here. And analytically, we can solve with analytical method using concept of Pythagoras. Yeah? this distance actually this square plus this square, isn't it? And you know, this is r square and this is n square. So it's become like two variable here, d distance as a function of n and r. To simplify, we can also express n in terms of r. For example, here we using trend line is fine. Yeah? We make this equation n versus r. So n is expressed in terms of r. Then finally we only have d as a function of r, and then we do first differentiation equation dd per dr equal to 0. We will find the optimum point. And it is about process design. I also just give example, not merely based on my experiment, but some I will also show up my experiment a little bit. This is like what I mentioned in the beginning, how to design the sequence of distillation column. So actually, we want to have minimum cost in this case. And the minimum cost here, the cost here will be proportional to the vapor which is produced by each column. And the total column, yeah, the total mole of vapor produced by the total column here. And we have this equation to correlate that. So because this little bit complex in terms of, it is not complex equation, but phi here is affected by 3 variables. Complex because the variable is 3 and not only 1. So we can solve actually analytically without using differential equation. The configuration that we choose actually the one that gives minimum phi, total phi here. Another process design in chemical engineering area is like in batch filtration. Batch filtration, like here I put example plate and frame filter. Even though this is a batch filter, but is this still widely used, especially when the cake is valuable and the amount of cake is very, very small. And then actually why we need to optimize this one, because of the fact that during the process, actually not only the time of process is not only filtration, it is batch process. So instead of except time for filtration, we need also time to clean, time to dumping, for dumping, and then for washing also. So not merely all for process of filtration. So increasing time of filtration, when we operate this filtration in batch increase time, then it's not guaranteed. It will increase the capacity of filtrate daily. No, not guaranteed. Why? Because it is batch. In one cycle, yes, maybe the volume will increase if we increase the time for filtration. But remember, time not only for filtration. So let's see example directly from the book. Yeah, I took from Brown with operation. This is leaf filter. Another example, batch filter. So the first condition A, actually we operate this one. We operate this one batch, and then we operate filtration for 1 hour, and then we keep the distance, the different in pressure drop 40 psi, for example, and the thickness of cake here from it's about 3.4 in 1 hour, and the volume of filtrate that we get 1,500 gallon. And then we stop, yeah, we clean, we dumping, we wash, we use washing water 300 gallon, and it's about 20% of this one. The question is how many gallons of filtrate produced per 1 day or per 24 hours? Yeah, because in one cycle of batch here, actually the time is not 24 hours here. So there are some cycles in 1 day. And the same question, similar question B, when we stop filtration not until 60 minutes, we stop like the thickness, yeah? Not until 3/4 in, but we stop the filtration until half in. How many gallons that we get? Maybe our imagination, maybe if we stop 1.5, yeah, half inch, the capacity in 1 day will be lower than A, maybe in our imagination, but in fact it's not like that. Yeah. Okay, this is the result. I don't need to explain this equation. This is chemical engineering that we can derive from continuity equation from the mass balance, etc. So this is the equation that we use, and then the answer condition A actually, when we stop filtration for 1 hour or the thickness 3/4 in, we have this capacity in 1 day. The field rate is about 21,600 gallons per day. And when we stop the thickness of cake half in, that means it is less than 1 hour. When we calculate using this equation, then we have this one. T is 26 point blah, blah, blah. As a matter of fact, this time of cycle, we have time filtration, washing, and this is fixed. Fixed means not depending on the condition of we stop, when we stop, but we consider the same. This is 16 minutes. So we have this answer, 27,000 gallons per day. That's mean in these two conditions, when we stop the filtration yearly, then the first one, in fact, we get the higher capacity. Why? Because the number of cycle here, time of cycle is less than, so the number of cycles in 1 day more than A. And we try to simulate from the two conditions. We try to simulate like something like this. If we just simulate by a good number like this, 0.5 thickness, 0.4 thickness in, 0.3, 0.2. From this good number, we have this optimum condition that the maximum capacity in 1 day is 29,000 blah, 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 gallon. And then the thickness actually 0.3 here. The time for filtration is what? 9.6 minutes. But from this data, from this simulation, we can derive mathematically. We just correlate that, okay, TS, time cycle, actually affected by volume of filtrate from this equation, this one, affected by this one. And this is constant, we consider this constant is constant. And from the data here, we have this one. Yeah. Finally, we have this one. TW also is affected by V because washing volume is also affected by V. We can correlate like 20%. Finally, we have this one. We have this one. So if we want to optimize, we can modify. Actually, if we want to maximum capacity in 1 day, that means maximum V per TS. Not only V, because it's only V this is the highest, but in the cycle time is this one. Yeah, we have the cycle time, this one. Yeah. So this is for this time. Yeah, longer time also. Yeah, total time is longer, not only duration. But okay, that means we must modify. The one that we must optimize is TS per V will be minimum, or V per TS will be maximum. V per TS maximum, TS per V minimum. Why we choose TS per V formulation? Because it will be simpler than V per TS. So in this case, we have optimization to minimize TS per V instead of maximize V per TS. So by differentiation, like usually in mathematics, dTS per V to dV, then finally we have, in this case, the actual V optimal per cycle actually 654.6 gallon, not only 600 like this. Yeah, this one. And then the thickness, the optimum thickness at 0.2, blah, 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 and etc. This is just another example for process design, and I took this from my research actually. This is for preparation of aroma compounds, which has very low solubility in water. We have preparation using membrane here, and then here actually the result here. From the very low concentration of aroma compound here, like less than 0.5%, I think, yeah, it's about 500 ppm or maybe a little bit more. Still in ppm, but here in the product here, it can be until 50%. Very, very high increase. But don't, selectivity is high, but this is low flux. Yeah. That's membrane actually. The capacity to pass through this membrane actually low. Yeah, but we can increase by using module membrane. Here actually in normal perforation, we recycle only the retentate here. the one that doesn't pass through the membrane, we return back to the feed here. But here we modify the process because here the concentration of aroma compound, which has very low solubility and water. Actually here when we leave in the counter, there will be two phases, and the two phases here in aqueous phase, there is still some amount of organic. And here we recycle this this organic. In other that we can recover the organic compound is higher. This is the result of simulation. Conventional is the red one. There is optimum, but here in this case, we increase the recovery by recycle the organic phase here. So it is another example of design of process, but yeah, this is like this also optimum. Yeah, we can say this not really optimum point because from the peak it is not really peak, yeah, but it's like equilibrium. It's like the constant value. Yeah, it's not really optimum, but anyway, it will increase the recovery of this one. And then the last one of theme of product design, actually, yeah, the similar principle with the equipment and process. So product design here actually describe the process of imagining, like what Professor Walidah and Dr. Yudi also explained. It's related to product design actually. It's a little bit different with the product in the plant. Yeah, in the plant usually, in chemical plant usually this intermediate, but for product design here, usually for end user customer. But the principle is same. The principle is same that we use optimization of product design in terms of determining the conditions of any affecting variables, any factors that affect the product here, and to give the best result of the goal, to give the best objective result. Yeah. And maybe I can like give a little bit comparison. Anyone can correct my comparison here. Yeah. Experiment optimization of equipment, process, and product design here. Based on affected variables, equipment usually dimension, it is like equipment variable, operating conditions, and then process design also similar, operating condition, the type of process. But for product design, it's not only chemical aspect, engineering aspect, function of course, yeah, aesthetic maybe, or what the shape, the good shape for the product, ergonomic, how to use comfortably, yeah, that's also considered. And then objective function, the principle is the same. For equipment design, usually related to cost. So the type is minimization, to minimize. And then process design also related, the objective function related to cost, maybe pollution also, to minimize. And then for product design, it's like quality of product characteristic to maximize usually. Yeah. And then type of product, we can compare also if it is equipment. So it is a device that usually used in the process. It can be general, I mean, when we design a storage tank for pressable water, it can be also used for similar liquid, yeah, not only water. And then general, and then also process design. The product is usually intermediate product, not directly end user customer. It will be processed in other plant maybe. And for product design, it is usually end product used by end user customer. And relatively specific, yeah, specific. Okay, I add a little bit about the use of optimization, and it is also usually used in engineering. Yeah? We can also use optimization when we want to build an empirical equation, but it is also done, already done. We need to do effort to like make programming to find the empirical equation, but the concept actually using also optimization. Like in Excel, when we choose trend line, which one the equation that's matched very well with the data, that's actually using concept of optimization. The optimization here actually minimization of the error, and the better one, not only error, it is the error, sum of error that's squared, sum of squared of error. I forgot to put half here, SSE here. Yeah. So the definition of SSE is the summation of this is the data from calculation, from the equation that we propose, and then this is from the data. It's dependent variable calculated from the proposed equation, and this is the dependent variable from the experimental data. And V squared means, okay, if less, the lower deviation will be the lower again if we quadratic. That's the logic actually. So, for example, this very simplest equation. For example, we know the trend data is like linear, and then we know the data like the intercept is like 0. It's passed to the central coordinate 0, 0. Then we have this formula J equals to AX here, and using the concept of differentiation, the minimization of this error, we can differentiate this objective function to the variable a here. The variable is a, not x. Yeah. The best equation is the a equation. The best equation is the a that gives the lowest SSA here. So when we have this equation, and then we differentiate this one equals to 0. Finally, we have this one. This one, and we can find the value of a from the differentiation of the SSA to the a to a. We have this formula. Yeah, this is example. For example, we have this is the independent variable in the experiment. The data that we vary the independent variable, and this is the measured data. The dependent variable that we calculate, that we measure from the experiment. And then actually we choose y equals to x after we know the data here, plotting data here. Okay, this linear, and okay, this looks like passing through the 0, 0 here. Then we have this formula, and then how to calculate a, actually using this equation, sigma summation of yx times xi, and then divided by summation this one, divided by this one, we have this one, 0.201. So the best empirical equation to express this data, to matching this data, actually this one, y equals to 0.201x. And I check using Excel, trend line, it gives exactly the same result here. Yeah, actually the trend line, the software, any software, it is built from the same concept here. And the concept is like this. This is from my experiment, is for this one. Yeah. I studied about perforation. Perforation means it is separation by membrane, and the membrane is dense membrane, non-porous membrane. I spirit aroma compounds. It's organic that has good perfume, good aroma, usually used in the pharmacy or cosmetic or food product to give good smell. And it is available in natural sources, like maybe in any plants, in the leaf, especially in the leaf or in the flower. And the amount of natural aroma compounds in the natural sources is very, very small. Then we can check using perforation. Why? Because first we dissolve in water, very much water, and then and this is the typical separation by membrane. The membrane will pass through just small amount. The component that pass through through the membrane actually small amount. So that's why we can take the small aroma compound in the aqueous solution. Yeah. And this is actually I try to correlate between the physical chemical properties of permean and membrane. Permean means the component that pass through the membrane, and then the membrane itself, and process condition like temperature, pressure in the vacuum, and etc. And I collect secondary data from the literature, and I check the chemical process, whatever, like solubility, for molar volume, temperature, and then also process condition like temperature and then pressure in the permeate. Then I did with polymath, nonlinear regression with these things. Yeah, this we can derive from dimensional analysis. Then finally I have this equation. Yeah, this equation. Yeah, this actually by optimization also to minimize the error or the SSA. And to find this one, I use this one. It is called data training. Yeah, data training to check to verify whether it's valid or not. I test with other data, like this one is just maybe 20 or 90 data here, and this is the comparison between calculation and experimental data. Of course, the data here is different from the training data. It is testing data. That's the end of my presentation. So because it's like general lecture, yeah, I'm sorry for that. I think we agree all that optimization plays a significant role in the design of equipment, process, and product. And then actually with the advantage, with the advance of methods, yeah, to derive and to solve, there are no particular obstacles in deriving of the objective function of any issues and solving their optimization due to the availability of various methods of repression and solution. And then the last one, it is recommended to state the range of studied independent variables or constraints when the objective function is not unimodal. Because maybe if we conclude this is the optimum condition, but maybe in other range of the condition, maybe it is not the optimum one. Yeah, it's just to for the safety conclusion. Yeah, I think it's enough for my presentation. Thank you very much for the attention. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. Yeah, thank you very much, Dr. Mujibur Rahman, for the very interesting and inviting presentation. So it's very inviting for a warm discussion. Yeah. Dear participants, before we proceed further, I do apologize for forgetting to introduce myself in the beginning of this session. So actually my name is Eko Setiawan. I'm from Industrial Engineering Department, Engineering Faculty, Universitas Muhammadiyah Surakarta. I really do apologize again for these mistakes. Okay, we still have plenty of time to discuss what Dr. Mujibur Rahman presented previously. And for the first chance, maybe any questions or any feedback from the audience. And before you convey your questions or feedback, please mention your name as well as your institutional affiliation. Please, maybe from anybody in this room? Yeah, it is about the concept of optimization in terms of related to equipment, process, and design. Yeah. Oh. Okay. Check, check. Okay, can you hear my voice, participants? How about this?
Yes.
Boo. Okay, thank you very much. Yeah, thank you for the feedback. Okay, dear participants, maybe any questions or maybe some thought. Okay, Admin 10, please. Time is yours.
Yes. Is this clear?
Ya, oke, Pak Malik Mustafa.
Okay, thank you for the time. Very short question to Dr. Mujib. We have several parameters in our optimization, and then we got the results. I mean, the most optimum. It's mean always the lowest price, or depend on the case. That's the question. Thank you.
I need to answer directly, Pak Eka, or maybe we need to wait other questions.
Okay, maybe Dr. Mujibur Rahman can give response to what Pak Malik Mustafa has as a question to you.
Yeah, thank you, Pak Malik, for the questions. Yeah, actually depends on the case. I absolutely agree with what you have said. It depends on the case. If the case is about the cost, that will be the case for minimization. And then if it is about profitable, and we want to, for example, I am now in the financing department. If we want to increase the revenue from other factors like other tuition, then we can optimize by maximizing. It depends on what factors that we can effort. Yeah, we can afford to make the increase in the profit. So again, it depends on the case. Yeah, if it is related to expense and cost. Manufacture, for example, that will be minimization. I think that's Pak Malik. Thank you.
Okay, any feedback, Pak Malik? Any more, maybe different insights or?
Thank you. Just to appointment. Like, so the lowest price, not always the most optimum. Depend on the case. I think that's the point. Is this correct?
The perfect objective function is Jadi model. Actually, Jadi model means only one optimum point that we have, and then that's mean it's applicable for your statement that the lowest minimum is the most optimum. But in case there are optimum points then more than 1 point, then the lowest one is still minimum point, but this will be called a specific term like global minimum. Yeah, and the global minimum, of course, that's the lowest one. Yeah, and it will be applicable for all in the range. Yeah. That we observe of factor variables. That's Pak Malik. Hopefully, it's already answered your questions.
Okay, thank you. It's very clear.
You're welcome, Pak Malik.
Okay, thank you very much, Pak Malik. Any other question? Maybe from the. Okay, Ibu Mila Failasufa, before delivering your question, please mention your name as well as your institutional affiliation. Thank you.
Okay. Yes, thank you, Mr. Eko. Let me introduce myself. I am Mila Failasufa from Industrial Engineering, Universitas Muhammadiyah Surakarta. I want to ask Mr. Mujib, can the optimization equation be used for all design and product process? In industrial engineering, we have the method called robust design that define maybe some evaluate your equation you just for us before, or maybe you can find some similarity, or your equation was can apply in some specialty case only, or we can apply for all the process equipment product design. Thank you.
Can I answer directly, Pak Eko? Yeah.
Yes, of course, Pak Mujib.
Thank you, Bu Mila. Yeah. So the type of equation that we can build for optimization, that depends on the depends on the case, on the problems that we looking at. The principle is that I think the same principle, I would say the same principle, yes. When we build up an objective equation, we identify first the objective, the target variable, the dependent variable, one that we want to optimize. And then the second step, we identify whatever the variables that affect these dependent variables. That's the principle. And then once we, when we derive the equation, the objective function, we can use analytical method or maybe empirical. Yeah, empirical, we just matching the data like trend line in the Excel. And then for analytical, we use some relevant theory with the case, yeah. And then that's the first my answer, that the same principle, yes. And then the second one, of course, we also have the same principle in solution. Yeah, once we have the objective function, how to solve, actually also we have the same principle. We can use sorry. I'm sorry. When I said I'm mute, yeah, Pak Eko, or when I explain, when I intro, not mute, because I know just mute. I don't know whether when I answer, my voice can be heard by Kumila. Pak Eko, when I answer the question.
Yes, please carry on, Pak Mujib, and please apologize for any for the technical issues previously. Please.
Yeah, in principle, depends on the case, yeah, and then of course, if different case, we will have different type of objective function, and the objective function actually is still open also, open equation. Some people may have different objective function with other people. It depends on what kind of variables affecting that they take into account. Yeah, of course, the more variable affecting, usually more valid, yeah, more valid, because we have more variables that we can take into account. Yeah. And the principle in solving also actually similar. Yeah. We can use numerical method, or we can use analytical method. Numerical method, we just, now it's already advanced, I think, yeah, in programming. We just use software solver, just input some variable that must be input, and then we just choose maybe the type of equation that we want to optimize. That's my answer. Thank you.
Yeah, thank you, Dr. Mujibur Rahman. Bu Mila, any feedback maybe?
Thank you. That's enough for now.
Okay, thank you very much. Right, next question please from the audience. Right, while waiting for the next question, Dr. Mujibur Rahman, I also have several questions. Maybe you can share your thought on it. Yeah. In industrial engineering, we we are a bit familiar about the terminology of heuristics, meta-heuristics. Is it relevant to your topic? I mean, when we say heuristic, meta-heuristic, is it closely related to maybe the analytical method or numerical or any other method related to the optimization of equipment, process, and product, design?
Yeah, I would appreciate if I could also explain first what's the definition of this term. Yeah, I think in chemical engineering myself, I am not very familiar with the term. If you can explain, can you please explain the terminology of what you said? What heuristic? What's it?
Yeah. So when we from the industrial engineering point of view, yeah, when we try to get something optimized, maybe we cannot reach that due to the time availability, due to the costs we have to have. So instead of getting optimum solution, then it comes the idea of heuristics, meta-heuristic, which is simply trial and error, something like that. So a near optimum solution, we could say. And when I see your presentation about, especially about numerical method, then it comes to my thought: is it related to heuristic, meta-heuristic, or is it actually two different terms or something else?
Yeah,
something like that, Dr. Mujib.
Yeah, thank you very much for your explanation. Yeah, from your explanation, I agree. I believe that that method also actually it is one type of numerical method. Yeah, because you said it is trial and error. Yeah, the nature of numerical methods is usually it is just simple calculation. It is repeated many times, and the solution sometimes is not exactly the same as if we use perfect theory, mathematical theory. Yeah. So, but in practice, even though the result is not exactly the same as using analytical method, sometimes it's already useful, very useful. Yeah. Instead of we try to solve using analytical method, maybe time consuming, we can just solve with trial and error, and then the result is not far different. In practice, it's already useful. It's okay. Yeah. So I think that's my answer. That it is typical numerical method, Pak Eko. Yeah. It's like other numerical methods.
Yeah. Thank you very much, Dr. Mujibur Rahman.
You're welcome.
Yeah. Any other questions, please, from the audience? Oh yeah, Bumila?
Yes, Mr. Eko.
Another question, or is it the same raise hand?
The same raise hand.
Oh, okay. Apologize for that. Yeah, dear participants, maybe any questions? Right. I still have another question, Dr. Mujibur Rahman. I hope you don't mind giving any answers or any ideas. When we talk about optimization, again, from the industrial engineering perspective, we usually use simulation. Is it relevant if we talk about simulation in this matter? I mean, if it is associated with your topic?
Yeah,
Thank you.
of course. Yeah, of course, Pak Eko. So simulation actually, it's a little bit more general than optimization, because simulation is like we try to calculate some things using the equation that we built up. Yeah? But the case is not always optimization. So simulation is more general than optimization. But simulation, of course, can be used for executing optimization problem. Yeah. Once the equation that we simulate is an objective function and there is optimum point there, so we can also solve using simulation. It's like also trial error also. That's my answer. Yeah.
Okay, thank you very much, Dr. Mujibur Rahman. Again, any other question? Okay, if there is no more question, we will give you, Dr. Mujibur Rahman, a little bit appreciation in the form of a certificate of appreciation. And please, the committee, please do display the certification for Dr. Mujibur Rahman. Okay, this is a certificate of appreciation from the Icetia committee for Dr. Associate Professor Dr. Muhammad Mujibur Rahman as a keynote speaker for this conference. And on behalf of the committee as well as the participants, we would like to give Dr. Mujibur Rahman full of thankfulness for sparing his busy time. We already know that you are very busy, Pak Mujib, for sparing your busy time with us in this conference. Thank you so much, and dear participants, please give a big applause for him. Yeah, again, thank you so much, and of course, we really do hope that you are still with us, Dr. Mujibur Rahman, for the next events of the conferences, Icetia, or maybe another conference held by the UMS. Thank you so much, and we've come to the break session. For that, we have around 1 hour and 18 minutes. Sorry, 1 hour and 8 minutes. Yeah, I guess we will be back at 1 o'clock. And as a moderator, if there are any mistakes I've made, I want to apologize. And billahi taufiq wal hidayah. Assalamualaikum warahmatullahi wabarakatuh. Okay, it's time for us to have a break for around 1 hour, 12 minutes. Thank you.
Thank you very much, Pak Eko, and all the member committees and audience.
Yeah, thank you so much, Dr. Mujibur Rahman. Okay, dear participants, as I mentioned before, we are coming to a break session, and please join the Zoom meeting at 1 o'clock sharply. Thank you.
Surakarta, atau dikenal dengan Solo, merupakan kota terbesar kedua yang terletak di Jawa Tengah. Dengan tagline The Spirit of Java, Solo menjadi kota yang
Recording
sangat... Surakarta, atau dikenal dengan Solo, merupakan kota terbesar kedua yang terletak di Jawa Tengah. Dengan tagline The Spirit of Java, Solo menjadi kota yang sangat ramah dan penuh dengan budaya. Salah satu hal yang menjadi daya tarik masyarakat datang ke kota Solo adalah pendidikan. Didukung sarana pendidikan mulai dari taman kanak-kanak hingga pendidikan tinggi, Solo tetap mengedepankan pendidikan sebagai prioritas yang tidak dapat dikesampingkan. Universitas Muhammadiyah Surakarta sebagai Universitas Muhammadiyah ternama di Indonesia. Terletak di kota Solo, Universitas Muhammadiyah Surakarta telah mengabdikan diri dengan menyumbang sumber daya unggul kepada negara Republik Indonesia. Sejak didirikan pada tahun 1958, saat ini Universitas Muhammadiyah Surakarta berhasil menempati 10 besar jajaran perguruan tinggi terbaik di Indonesia. Hingga kini, Universitas Muhammadiyah Surakarta telah memiliki 12 fakultas dan 60 program studi. Fakultas Ekonomi dan Bisnis, Fakultas Kedokteran, Fakultas Teknik, Fakultas Komunikasi dan Informatika, Fakultas Ilmu Kesehatan, Fakultas Keguruan dan Ilmu Pendidikan, Fakultas Farmasi, Fakultas Psikologi, Fakultas Geografi, Fakultas Agama Islam, Fakultas Kedokteran Gigi, Fakultas Hukum. Selain program studi sarjana S1, Universitas Muhammadiyah Surakarta juga menyediakan program pasca sarjana S2 dan S3. Untuk menunjang pelaksanaan belajar mengajar, Universitas Muhammadiyah Surakarta dilengkapi dengan sarana dan prasarana yang memadai. Universitas Muhammadiyah Surakarta, wacana keilmuan dan keislaman.
UMS adalah pilihan yang tepat bagi saya dalam pengembangan diri dan prestasi. Tidak hanya kegiatan perkuliahan di kelas, sederet kegiatan organisasi kemahasiswaan serta pendampingan yang dilakukan secara intensif menjadi alasan tersendiri bagi saya untuk tidak memilih kampus lain sebagai tempat melanjutkan studi. Universitas Muhammadiyah Surakarta, unggul mencerahkan semesta.
Alhamdulillah, saya sangat bangga menjadi bagian dari Universitas Muhammadiyah Surakarta yang terakreditasi unggul. Atmosfer akademik yang sangat kondusif, fasilitas lengkap, serta hubungan yang harmonis antara mahasiswa, dosen, maupun karyawan. UMS memberikan dukungan yang penuh kepada saya dalam mengembangkan prestasi saya.
Assalamualaikum warahmatullahi wabarakatuh. Universitas Muhammadiyah Surakarta adalah salah satu kampus terbaik di Indonesia yang menyandang predikat sebagai kampus unggul. Dengan dukungan sumber daya manusia yang sangat berkompeten, fasilitas yang lengkap, serta iklim akademik yang sangat baik, maka UMS berkomitmen untuk memberikan layanan yang terbaik bagi mahasiswa. Tidak hanya kemampuan akademik, tapi juga pengembangan soft skill maupun prestasi serta minat bakat mahasiswa. UMS unggul mencerahkan semesta. Wassalamualaikum warahmatullahi wabarakatuh.
Dengan langkah tegak, putra putri bangsa berjiwa satria, berakhlak mulia, sebagai lentera menyinar
satu kota yang paling nyaman untuk ditinggali di Indonesia yang terus berkembang pesat dengan kehidupan sosial masyarakatnya yang heterogen, toleran, dan damai. Dalam perkembangannya, kini Solo juga tumbuh menjadi salah satu kota berpendidikan yang sangat diperhitungkan. Salah satu pilar penyangga pendidikan tinggi utama di Solo adalah Universitas Muhammadiyah Surakarta. Universitas yang berdiri di bawah Perserikatan Muhammadiyah ini berdiri pada tanggal 24 Oktober 1981 sebagai perubahan bentuk dari Institut Keguruan dan Ilmu Pendidikan Muhammadiyah Surakarta. Fakultas Teknik Universitas Muhammadiyah Surakarta memiliki visi menjadi pusat pendidikan dan pengembangan iptek, ilmu pengetahuan teknologi dan seni, dan memberikan arah perubahan di bidang keteknikan berdasarkan nilai-nilai keislaman pada tahun 2029. Fakultas Teknik Universitas Muhammadiyah Surakarta mendidik mahasiswanya dalam lingkungan Islam dengan menghasilkan lulusan sarjana S1 yang berakhlak mulia, profesional dengan senantiasa menjunjung tinggi nilai-nilai idealisme.
Assalamualaikum warahmatullahi wabarakatuh. Selamat datang di Fakultas Teknik Universitas Muhammadiyah Surakarta. Kami adalah salah satu di antara 14 fakultas di Universitas Muhammadiyah Surakarta yang menyelenggarakan 6 program studi sarjana, 3 program studi magister teknik, dan 1 program profesi insinyur. Sejak tahun 1981, selama lebih dari 40 tahun hingga saat ini, kami telah berkontribusi turut serta mencerdaskan kehidupan bangsa dengan meluruskan, mencetak dan meluruskan para sarjana teknik yang hingga saat ini telah sebar di seluruh Indonesia, bahkan ada yang bekerja di mancanegara. Sebagai bagian dari Universitas Muhammadiyah Surakarta yang memiliki visi menjadi pusat pendidikan dan pengembangan ilmu pengetahuan, teknologi dan seni yang islami dan memberi arah perubahan, Fakultas Teknik Universitas Muhammadiyah Surakarta mengemban misi universitas, yakni 2 hal. Yang pertama adalah mengembangkan ilmu pengetahuan dan teknologi, dan yang kedua adalah mengembangkan sumber daya manusia di bidang teknologi yang islami sehingga bisa berkontribusi dalam mewujudkan masyarakat yang utama. Secara kelembagaan, Fakultas Teknik Universitas Muhammadiyah Surakarta hingga saat ini telah mendapatkan pengakuan dari lembaga akreditasi baik tingkat nasional maupun di tingkat internasional. Di tingkat nasional, 6 program studi dari 10 program studi yang ada di Fakultas Teknik telah memiliki akreditasi A atau unggul dari Badan Akreditasi Nasional Perguruan Tinggi. Di level internasional ada 2 program studi yang mendapat sertifikasi dari AUNGE (ASEAN University Network Quality Assurance), yakni program studi teknik sipil dan program studi arsitektur. Kemudian juga ada 2 program studi, yakni program studi teknik industri dan program studi teknik kimia yang mendapatkan akreditasi dari IAB. Teknik industri sudah general accreditation, sedangkan teknik kimia baru status profesional accreditation. Di bidang sumber daya manusia, dosen-dosen di Fakultas Teknik Universitas Muhammadiyah Surakarta telah memiliki kualifikasi pendidikan yang sangat membanggakan. Lebih dari 60% dosen sudah berkualifikasi S3 dan sebagian besar di antara mereka sudah berkualifikasi lektor kepala dengan 4 profesor, 3 di antaranya dari program studi teknik. Di bidang mahasiswa, banyak sekali prestasi yang telah diraih oleh mahasiswa dari Fakultas Teknik Universitas Surakarta, baik di tingkat nasional maupun internasional. Untuk proses pembelajaran, kami berkomitmen untuk memberikan pengalaman pembelajaran yang berstandar nasional maupun internasional. Hal ini ditunjukkan dengan implementasi kurikulum berbasis outcome-based education, di mana kami mengadopsi kurikulum framework CDIO dan kami mengajukan akreditasi internasional. Untuk menghadirkan atmosfer internasional, kami menerima mahasiswa dari mancanegara. Saat ini tercatat ada 50 mahasiswa full-time dan 109 mahasiswa part-time dari luar negeri. Semua ini kami lakukan untuk mendukung terwujudnya tujuan pengelolaan Fakultas Teknik, yakni menghasilkan lulusan yang berakhlak mulia, profesional, kreatif, dan inovatif. Sebagai bagian dari amal usaha di bawah Persyarikatan Muhammadiyah, tentunya kami memberikan muatan lebih kepada mahasiswa kami dengan berbagai kegiatan keagamaan, baik yang kurikuler maupun yang ekstrakurikuler, misalnya Baitul Arqam, kemudian lomba-lomba di bidang keagamaan sesama perguruan tinggi Muhammadiyah. Kami juga berpartisipasi, mahasiswa kami mencapai prestasi yang monumental. Misi pengembangan ilmu pengetahuan dan teknologi kami upayakan dengan menyediakan fasilitas penelitian, kegiatan penelitian yang dilaksanakan oleh dosen yang bekerjasama dengan mahasiswa dalam pengusahaan skripsi atau tesis yang hingga saat ini telah menghasilkan luaran baik berupa jurnal, paten, hak cipta, teknologi tepat guna, perwarupa, dan lain-lain. Prestasi para dosen dan mahasiswa di bidang akademik dari Fakultas Teknik Universitas Muhammadiyah Surakarta telah banyak memberikan kontribusi dalam pencapaian Universitas Muhammadiyah Surakarta sebagai World Class University dalam 5 tahun. Terima kasih yang sebesar-besarnya kami ucapkan kepada masyarakat yang telah memberikan kepercayaan kepada kami untuk menjalankan visi misi kami mencetak sarjana di bidang teknik yang unggul yang berkontribusi untuk menciptakan masyarakat yang utama. Mohon doa selalu, mohon dukungannya agar kami tetap bisa menjalankan amanah ini dengan sebaik-baiknya. Assalamualaikum warahmatullahi wabarakatuh.
Fakultas Teknik Universitas Muhammadiyah Surakarta memberi jawaban atas kelemahan dunia pendidikan dewasa ini yang hanya fokus pada transfer ilmu pengetahuan. Fakultas Teknik Universitas Muhammadiyah Surakarta memiliki visi menjadi pusat pendidikan dan pengembangan iptenas.
Jurusan Teknik Sipil memiliki visi menjadi rujukan dan pengembangan ilmu teknik sipil berdasarkan nilai-nilai keislaman yang memberikan arah perubahan dan kemajuan teknologi. Misi Prodi Teknik Sipil adalah mendidik sarjana teknik sipil yang kompetitif dan profesional, kreatif, serta inovatif.
Jurusan Teknik Mesin memiliki lulusan yang telah tersebar merata di berbagai industri di Indonesia, memiliki visi sebagai pusat unggulan pendidikan dan rekayasa dalam bidang otomotif industri, yang menghasilkan lulusan berkualitas tinggi, yang relevan dan kompetitif di pasar global. Tentu saja dengan menghasilkan sarjana berakhlak mulia, berwawasan keislaman, serta memiliki dasar pengetahuan yang kuat, profesional, dan mampu mengembangkan diri pada bidangnya. Jurusan Teknik Mesin memiliki misi untuk mendidik mahasiswa dan mahasiswi menjadi sarjana teknik yang kompetitif dan profesional di bidangnya. mampu bersikap independen dan menyelesaikan diri, serta menjunjung tinggi moralitas.
Teknik arsitektur sebagai bagian dari Fakultas Teknik turut mengemban visi dan misi dengan berupaya meningkatkan mutu dan relevansi program pendidikan sesuai dengan pendidikan profesional arsitektur. Pendidikan dititik beratkan pada latihan terstruktur dan dapat memberikan kontribusi pengembangan sumber daya manusia yang terampil, fleksibel, serta mampu mengikuti perkembangan teknologi. Visi dari prodi arsitektur adalah sebagai pusat pendidikan arsitektur yang profesional dan berdasarkan nilai-nilai keislaman dan berkelanjutan.
Jurusan elektro bergerak dengan slogan BES, beriman, cerdas, terampil, dan profesional, sesuai wacana keilmuan dan keislaman. Jurusan teknik elektro memiliki visi menjadi pusat unggulan di bidang sistem tenaga listrik, sistem elektronika, dan sistem komputer, sehingga mampu menghasilkan lulusan yang berkualitas iman, serta profesional amalnya yang kompetitif dalam pasar kerja.
Program studi teknik kimia bertujuan untuk menghasilkan sarjana teknik kimia yang islami dan berkemajuan
dalam bidang penelitian dan pengabdian masyarakat, berupaya untuk mengembangkan teknologi bersih dan teknologi tepat guna dalam memenuhi tuntutan industri lokal. Teknik kimia UMS berupaya untuk meningkatkan isolasi serta pemanfaatan kimia bahan alam, sehingga untuk mencapai tujuan tersebut, teknik kimia menjalin kerjasama dengan industri-industri kimia terkemuka.
Program studi teknik industri memiliki visi menjadi pusat pengembangan keilmuan teknik industri yang berkelanjutan, profesional sesuai dengan nilai-nilai keislaman dan tuntutan zaman untuk memberikan arah pada pendidikan. Sedangkan industri teknik industri adalah menyelenggarakan pendidikan yang berkualitas dalam bidang perancangan, penginstalasian, dan perbaikan sistem industri dalam lingkungan yang islami, sehingga menghasilkan profil lulusan yang berkualitas, profesional, serta berakhlak keislaman.
Berawal dari mimpi besar untuk meningkatkan derajat kesehatan gigi dan mulut, Universitas Muhammadiyah Surakarta telah berhasil mewujudkannya dengan mendirikan Rumah Sakit Gigi dan Mulut Sulastri yang terletak di jantung kota, tepatnya di Jalan Brigjen Slamet Riyadi nomor 366 Surakarta. Rumah Sakit Gigi dan Mulut Sulastri atau yang lebih dikenal dengan RSGM Sulastri adalah rumah sakit khusus yang memberikan pelayanan kesehatan gigi dan mulut. RSGM Sulastri juga berfungsi sebagai sarana implementasi pendidikan bagi mahasiswa profesi Fakultas Kedokteran Gigi Universitas Muhammadiyah Surakarta. Dengan visi menjadi rumah sakit gigi dan mulut yang islami, serta berstandar internasional, didukung dengan sumber daya manusia yang unggul, sarana prasarana yang modern dan canggih. Kami bertekad untuk menjadi rumah sakit rujukan yang memberikan pelayanan profesional, islami, dan berfokus pada keselamatan pasien, sekaligus sebagai pusat pendidikan, penelitian, serta bentuk pengabdian untuk masyarakat di kota Surakarta. 24 jam sehari, 7 hari dalam seminggu, kami siap melayani dengan pelayanan gawat darurat. Rawat jalan, rawat inap yang nyaman, ditunjang fasilitas berupa ruang bedah sentral, farmasi, laboratorium klinik, Laboratorium Teknik Gigi, Radiologi Dental, serta OSCE Center yang terdaftar di Konsil Kedokteran Indonesia. Sebagai rumah sakit gigi dan mulut satu-satunya di kota Surakarta, RSGM Sulastri melayani pelayanan dokter umum, dokter spesialis, dokter gigi umum, dan dokter gigi spesialis di bidang konservasi gigi, ortodonsia, prostodonsia, periodonsia, kedokteran gigi anak, serta bedah mulut.
Editorium merupakan salah satu gedung yang dimiliki oleh Universitas Muhammadiyah Surakarta yang berlokasi di Jalan Yani Sucipto nomor 33, Colomadu, Karanganyar. Gedung yang bertempat di sebelah utara kampus UMS itu memiliki akses yang tidak begitu rumit. Dengan ini pengunjung akan jauh lebih mudah saat mengakses Editorium UMS. Dapat dilihat dari lokasinya yang dekat dengan Bandara Adi Sumarmo Solo dan pintu tol Solo Kertosono. Tagline dari gedung ini adalah Convention, Celebration, Exhibition, Art Space, and Sport Hall. Gedung Editorium UMS merupakan salah satu gedung convention hall terbesar di Indonesia yang terdiri dari 3 lantai dan basement. Memiliki kapasitas di hall utama dan 2 lapis tribun sejumlah 6.000 orang. Editorium UMS juga dapat diperluas hingga mencapai kapasitas total 8.000 orang. Uniknya, ada area yang akan diproyeksikan sebagai Museum Peradaban Islam di Asia Tenggara. Gedung ini dilengkapi dengan pendingin udara terpusat, juga dilengkapi dengan 4 eskalator dan 4 lift yang berada di samping pintu utama. Editorium UMS memiliki 10 ruang seminar di lantai 2 dan musola berkapasitas 800 orang di lantai 3. Editorium ini didesain ramah terhadap kaum difabel. Kawasan dari Editorium UMS dilengkapi dengan danau buatan, danau retensi untuk antisipasi banjir, musola, dan taman publik seluas 1 hektar bagi warga masyarakat Soloraya. Tak hanya itu, di editorium UMS juga terdapat playground untuk area bermain anak-anak, jogging track, dan alat olahraga. Keamanan pada editorium ini dilengkapi juga dengan 5 pos keamanan yang sudah tersedia puluhan CCTV. Penggunaan tenaga listrik di editorium UMS juga sangat ramah lingkungan. Hal tersebut dikarenakan editorium UMS memanfaatkan cahaya matahari sebagai salah satu sumber tenaga listrik. Ini juga sebagai salah satu wujud perhatian kita terhadap sumber daya yang terbarukan.
AHAS UMS Motor Group. AHAS UMS Motor Group merupakan bengkel yang dapat melakukan servis motor Honda terkait ganti oli rutin motor Honda, servis aki, servis rutin, ganti ban dan velg, ganti subbreaker, rem atau cakram, lampu, dan lainnya. AHAS UMS Motor Group beralamat di Jalan Garuda Mas, Bendungan, Pabelan, Kecamatan Kartasura, Kabupaten Sukoharjo, Jawa Tengah. Bengkel resmi AHAS Honda Kabupaten Sukoharjo ini melayani servis, perawatan dan perbaikan motor Honda berbagai jenis, mulai dari matic, bebek, kopling, sport, dan trail. Terdapat promo menarik untuk pembelian produk spare part Honda seperti promo potongan harga, diskon, hingga cashback. AHAS UMS Motor Group memiliki beberapa stasiun kerja, gudang park, ruang tunggu, dan kasir. AHAS UMS Motor Group memiliki ruangan yang terbuka dan terdapat alat pemadam kebakaran ringan atau APAR untuk keselamatan kerja jika terjadi kecelakaan kerja, kebakaran, dan lain-lain. Pelayanan AHAS UMS Motor Group antara lain terdiri dari KBP, servis, klaim, ganti oli, spare part HGP, pit express, booking service, dan motorku X. Khusus mahasiswa UMS akan mendapatkan potongan harga servis 50% jika KHS lebih dari 3,2. servis gratis jika KHS lebih dari 3,5, dan khusus mahasiswa baru mendapatkan potongan harga servis sebesar 25%. Jam operasional AHS UMS Motor Group mulai hari Senin sampai Sabtu dibuka pukul 8 pagi sampai 4 sore waktu Indonesia Barat. Hari Minggu dan hari besar AHS UMS Motor Group libur. Pratama Muhammadiyah Medical Center atau MMC yang beralamat di Jalan Garuda Mas, nomor 6, Pabelan, Kartasura, Sukoharjo, di mana Muhammadiyah Medical Center ini masih satu area dengan lingkungan kampus Universitas Muhammadiyah Surakarta. Pelayanan yang terdapat pada Muhammadiyah Medical Center antara lain terdiri dari dokter umum, dokter gigi, dan fisioterapi. Muhammadiyah Medical Center melayani pemeriksaan untuk pasien umum dan pasien BPJS. Jam buka pelayanan Muhammadiyah Medical Center mulai dari jam 8 pagi sampai jam 8 malam. Sumber daya manusia yang terdapat pada Muhammadiyah Medical Center antara lain terdiri dari 2 dokter umum, 1 dokter gigi, 2 apoteker, 3 perawat, 3 administrasi, 1 pekarya atau OB, dan 2 asisten apoteker. Ruangan yang dimiliki oleh Muhammadiyah Medical Center antara lain terdiri dari ruang poli umum, ruang poli gigi, ruang tindakan, ruang fisioterapi, ruang pendaftaran, ruang tunggu pasien, toilet, ruang limbah medis. Dan untuk ruang limbah medis tidak bisa masuk dikarenakan merupakan zona beracun dan merupakan limbah infeksius. Apotek, dan kantor. Pelayanan kesehatan pada Muhammadiyah Medical Center bersifat gratis untuk mahasiswa dan sivitas akademika di lingkungan kampus Universitas Muhammadiyah Surakarta. Urutan alur pelayanan pada Muhammadiyah Medical Center antara lain 1. Datang, 2. Pendaftaran, 3. Masuk ruang periksa untuk dokter umum, dokter gigi atau fisioterapi, 4. Ambil obat, dan yang terakhir pulang. Setiap harinya pasien yang berobat baik dari mahasiswa ataupun sivitas akademika dan juga pasien umum mencapai kurang lebih 60-70 pasien per hari.
Universitas Muhammadiyah Surakarta yang bersemboyan wacana keilmuan dan keislaman mewujudkan kampus berbudaya Islami yang menguasai ilmu pengetahuan dan keterampilan yang dilandasi nilai-nilai keislaman. Semakin berkembangnya Universitas Muhammadiyah Surakarta dengan peningkatan jumlah mahasiswa dari tahun ke tahun dan keragaman daerah asal mahasiswa memerlukan pemenuhan kebutuhan tempat tinggal sebagai faktor penunjang kegiatan istirahat dan belajar. UMS juga ingin memfasilitasi mahasiswa seperti yang telah dilakukan perguruan tinggi lain yang telah memiliki asrama mahasiswa. Pesantren mahasiswa atau lebih dikenal dengan nama PESMA UMS dulunya adalah rumah susun mahasiswa atau rusunawa. Pada perkembangan selanjutnya, rusunawa ini dialihfungsikan sebagai pesantren mahasiswa internasional. Pesantren mahasiswa yang diberi nama Pesantren Mahasiswa Kiai Haji Mas Mansur yang kemudian lebih dikenal dengan PESMA KH Mas Mansur. Pengelolaan pesantren mahasiswa ini dipimpin oleh seorang direktur berdasarkan surat keputusan Rektor UMS. Dalam perjalanannya sejak berdiri tahun 2008 telah mengalami 4 pergantian direktur dengan moto Road to be Smart and True Muslim.
Kita mulai memberlakukan adanya pembatasan tinggal di PESMA. Jadi mulai 2015 kita adakan akhir sana. Mereka tinggal di sini selama 2 tahun. Setelah itu mereka kita wisuda akhir sana. Bagi yang bagus maka mereka boleh lanjut.
PESMA Internasional Kiai Haji Mas Mansur memiliki 2 organisasi penting yang ada di dalamnya. Yang pertama adalah International Student Organization, yang kedua adalah Ikatan Mahasiswa Muhammadiyah Komisariat Pondok Internasional Kiai Haji Mas Mansur. Peran kedua organisasi ini sangat penting bagi berlangsungnya kehidupan di PESMA. Salah satunya adalah mengatur segala aktivitas mahasantri, mulai dari kelas pagi, kelas malam, kegiatan jasmani dan rohani, dan di situ harus diikuti oleh seluruh mahasantri yang ada di PESMA Kiai Haji Mas Mansur.
Saya aktif di Ikatan Mahasiswa Muhammadiyah Mas Mansur, dan saya aktif dalam Muhammadiyah English Debating Society. Saya juga berperan aktif di PESMA sebagai tutor, sebagai room koordinator, dan sebagai staf pengajar di PESMA. Dalam semua organisasi tersebut, saya bisa membuktikan bahwasanya saya bisa menjadi lulusan terbaik di UMS pada periode saya di tahun 2018.
Jadi 2015 kita mulai melakukan juga tahfidz ini untuk mewadahi banyaknya mahasantri-mahasantri baru yang memang mereka tertarik dengan kegiatan tahfidz.
Bergabung dengan PESMA sangat membantu saya untuk mendapatkan manfaat, baik itu ilmu yang bisa kita terapkan di dunia maupun ilmu yang sebagai bekal kita di akhirat nanti.
Kami juga setiap bulan memberikan SMS Gateway yang isinya memberikan informasi tentang kegiatan di PESMA plus informasi tentang biaya. Selain itu adanya lorong edukasi, tempat di mana di situ anak-anak berekspresi dengan mural. Kemudian kegiatan yang lain juga kita punya duta PESMA. Jadi duta PESMA itu adalah nanti kita melakukan aksi sosial untuk masyarakat. Kita berharap anak-anak di PESMA juga berkontribusi dan ikut untuk kegiatan-kegiatan pencarian beasiswa ke luar negeri. Dan itu kita adakan mereka mengikuti kegiatan seperti Python. Kemudian juga kita punya ikatan alumni IKPESMA. Tujuan kami bagaimana PESMA ini tidak hanya melahirkan para mahasantri yang qualified dalam bidang akademik, tetapi akhlaknya juga bagus. Tetapi mereka juga punya skill-skill yang lain. Bahasa Inggrisnya kita juga gembleng lewat kegiatan scholarship fighter. Kita punya yang namanya Pancasila PESMA.
Selain itu di PESMA juga mempunyai 5 pilar yang harus kita junjung, yaitu yang pertama adalah kejujuran, keikhlasan, kerja keras, tanggung jawab, dan juga persaudaraan. 5 pilar inilah yang menjadi dasar bagi kita untuk menjalani seluruh aktivitas dan rutinitas yang berada di PESMA Mas Mansur.
Dengan 5 Pancasila itu bisa memberikan bekal yang luar biasa bagi santri-santri kami untuk kemudian nanti terjun di masyarakat dimanapun mereka berada.
Pesantren mahasiswa Kiai Haji Mas Mansur menjadi tempat belajar sekaligus pengkaderan bagi kader Muhammadiyah untuk para mahasantri agar siap berkiprah di tingkat nasional maupun internasional. Untuk menunjang hal itu, Pesma Kiai Haji Mas Mansur terus memberikan fasilitas yang memadai dan mentor yang kompeten. Pesantren mahasiswa terdiri dari Pesma Putra dan Pesma Putri. Untuk bisa tinggal di Pesma Kiai Haji Mas Mansur, tentu saja dengan persyaratan yang harus dipenuhi. Di antaranya, kapasitas Pesma Kiai Haji Mas Mansur menampung 400 mahasantri, mempunyai 2 gedung asrama, yaitu Asrama Putra dan Asrama Putri, baik mahasiswa reguler maupun mahasiswa internasional.
Saya merasakan di Pesma sangat nyaman sekali, karena fasilitas-fasilitas yang ditawarkan oleh Pesma itu sangat menarik sekali. Di antaranya yang pertama Sport Center. Kantin, tempat berkumpul bersama-sama dengan teman-teman, kebersihannya terjamin. Di Pesma juga mendapatkan laundry. Laundry ini sangat membantu mahasantri meringankan beban mereka untuk tidak mencuci.
As-salatu khairun minan naum. As-salatu khairun minan naum. Allahu Akbar, Allahu Akbar. La ilaha illallah.
Pesma Kiai Haji Mas Mansur mempunyai visi sebagai Center of Excellence atau pusat keunggulan dan sarana pembinaan kader pejuang dalam menghadapi dinamika dunia Islam baik secara lokal maupun global. Dengan misi 1. Membekali mahasiswa dengan pemahaman manhaj yang lurus dan komprehensif mengenai Al-Quran dan Al-Hadis. 2. Membuka cakrawala mahasiswa mengenai perkembangan dunia Islam baik secara lokal maupun internasional dalam interaksinya dengan dunia kontemporer. 3. Membekali mahasiswa dengan skill bahasa asing, yaitu bahasa Arab dan bahasa Inggris. Setiap mahasantri diberikan pembinaan secara intensif meliputi tauhid akidah, ibadah, muamalah dan akhlak. Diharapkan akan mampu memiliki kepandaian atau kecakapan dalam berbahasa Inggris dan bahasa Arab. Syarat lulus dari pesantren adalah setiap mahasantri wajib mengikuti evaluasi pembinaan yang diadakan setiap semester dan akan mendapatkan sertifikat kelulusan. Bekal ilmu yang didapat selama di pesantren diharapkan berguna bagi mahasantri untuk memiliki kesiapan baik secara fisik dan juga mental untuk berdakwah dan berjuang menyebarkan kemuliaan ajaran Islam di tempat tinggalnya masing-masing.
Pesma merupakan salah satu tempat untuk berproses dalam bentuk mental, karakter, dan juga kepribadian. Di Pesma saya merasa nyaman, dan di Pesma juga saya menemukan orang-orang yang hebat, orang-orang yang penuh motivasi dan penuh semangat, dan teman-teman yang selalu berjuang untuk menjadi orang yang lebih baik.
There are so many, like studying together with my friends, sharing many activities, like Quran, reciting, and many. So anyone who wanted to come here, we are welcoming you to come to Pesma. You will learn many things which is unbelievable for your future and good target for your lives. Thank you very much for your time.
Road to be smart and true Muslim. Pesma, yes, the best.
UMS Store adalah toko resmi Universitas Muhammadiyah Surakarta yang menyediakan berbagai macam kategori buku, jurnal, official merchandise, serta alat tulis perkantoran. UMS Store beralamat di Komplek Kampus 1 UMS, Jalan Ahmad Yani, Pabelan, Kartasura, Sukoharjo, Jawa Tengah dengan kode pos 57169. UMS Store merupakan pusat layanan program penukaran voucher mahasiswa yang diselenggarakan oleh Universitas Muhammadiyah Surakarta. Berbagai buku disediakan, diantaranya ada buku teks, kontemporer, pendidikan, filsafat, psikologi, hukum, kesehatan, kedokteran, komputer, teknik, penelitian statistik, bahasa dan sastra, Islami, dan masih banyak lagi. Toko kami juga dilengkapi dengan alat tulis kantor yang lengkap dengan harga yang terjangkau. Selain menyediakan berbagai macam kategori buku, UMS Store juga merupakan penyedia official merchandise sebagai barang yang mencirikan Universitas Muhammadiyah Surakarta. Beberapa merchandise yang ada di UMS Store antara lain t-shirt, jaket, tas, topi, pin, stiker, vendel, mug stainless, tumbler, gantungan kunci, boneka wisuda, dan atribut Muhammadiyah seperti batik, baju, kaos, badge, dasi HW, baju HW, bendera, dan lain-lain. Saat ini dengan adanya kemajuan teknologi informasi, maka UMS Store hadir dalam bentuk online sebagai jawaban atas tuntutan kebutuhan masyarakat modern. UMS Store Online merupakan transformasi toko fisik dengan segala keunggulan dan kelengkapan produknya. Pelayanan UMS Store. Tukar voucher di UMS Store. Untuk alur pelayanan penukaran voucher dimulai oleh mahasiswa aktif UMS, voucher mahasiswa senilai Rp100.000. Mahasiswa dapat mempersiapkan KTM asli atau kartu perpus, datang langsung ke UMS Store, pilih buku yang diinginkan, tunjukkan ke kasir KTM atau kartu perpus, bawa pulang buku yang diinginkan. Jam operasional toko offline mulai hari Senin sampai Sabtu, dibuka pukul 8 pagi sampai 4 sore, kecuali hari Sabtu hanya buka sampai pukul 12 waktu Indonesia Barat. Hari Minggu dan hari besar UMS Store libur.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh.
Dengan langkah tegak, putra-putri bangsa berjiwa satria, berakhlak mulia, sebagai lentera menyinari pertiwi, insan harapan nusa dan bangsa. Tekad kuat membangun negeri ini, berkompetisi dan berintegritas tinggi, jaga martabat dan profesionalisme, amalkan ilmu dengan karya nyata. Ibadah dan belajar jadi pola hidup, satu jiwa kita saudara sebagai moto. Universitas Muhammadiyah Surakarta, Fakultas Teknik Universitas Muhammadiyah.
Abdi.
Yuk.
Oh. Yeah.
Recording in progress.
Good afternoon, Dr. Abdi. Should I say good morning?
Yeah.
Okay.
Good afternoon, everyone.
Yeah, thank you. So welcome, Dr. Fatwa Firdaus Abdi. Yeah. Okay, ladies and gentlemen, Assalamualaikum warahmatullahi wabarakatuh. It's 1 o'clock sharp, as I mentioned before. So let's start the second part of the session 2 of this conference. And already with us, Dr. Fatwa Firdaus Abdi. He's very keen to spare his busy time. So we know that you are very busy, Dr. Abdi. Thank you very much for that, for joining us. Before we proceed further, participants, please allow me to to display Dr. Abdi's curriculum vitae. So many publications listed there. And as personal information, our speaker, his name is Fatwa Firdaus Abdi. Apologize for that. Forget to open my mask. And starting from 2006 until now, he has been having professional experiences, starting from process integration intern on yield improvement at Systems on Silicon Manufacturing Corporation Limited, Singapore, until from 2019 until now. He serves as Deputy Head of the Institute for Solar Fuels, Helmholtz Zentrum Berlin für Materialien und Energie, Berlin, Germany. And between this time frame, as we can see together from this slide, so many other professional experiences. Okay, Dr. Fatwa Firdaus Abdi got his undergraduate degree, a Bachelor of Engineering with minor in business. And this is really amazing, first class honors from School of Materials, Science and Engineering, Nanyang Technological University, Singapore. And then he obtained 2 different master's degrees. The first one is Master of Engineering from the Department of Material Science and Engineering, Massachusetts Institute of Technology, Cambridge, United States of America, as well as Master of Science in Advanced Materials for Micro and Nano Systems, National University of Singapore, and finally he got his PhD with cum laude within top 5% from Delft University of Technology at Materials for Energy Conversion and Storage, Department of Chemical Engineering, Delft, the Netherlands. Fellowships and awards, starting from 2003, until 2004, Dorothy Chung Scholarship for Study at NTU, Singapore. And then 2005 to 2006, Singapore MIT Alliance Fellowship for Master's Education at NTU, Singapore, and MIT, USA. In 2014, Dr. Abdi received Martinus van Marum Prize from the Royal Holland Society of Sciences and Humanities, or KHMW, for the best thesis in chemistry and chemical technology for the past 5 years. And so on until in 2019 until 2021, Dr. Abdi is one of the Stanford University ranking top 2% scientists in a single year. Regarding teaching activities, Dr. Abdi has had experiences at the University of Delft or Delft University of Technology in 2011 until 2013, and then guest lecturer for physical chemistry course at Pertamina University Indonesia in 2021, and at the same year, he also served as guest lecturer for functional materials course, Universitas Indonesia, and then 2020 until now, guest lecturer for applied electrochemistry course, FU Berlin, Germany, and from 2015 until now, he served as co-lecturer for photoelectrochemical energy conversion course at TU Berlin, Germany. Regarding supervision and mentoring, Dr. Fatwa Firdaus Abdi has supervised so many students, including bachelor students as well as doctoral and also postdoctoral students or researchers. And then he also has a lot of very long track record on coordinating and organizing projects, including serving as principal investigator and topic board member in the chemical energy carriers topic of Helmholtz Association's program oriented funding for materials and technologies for the energy transition program from 2021 until 2027. In terms of professional services, Dr. Abdi served as organizer for symposium on sustainable routes to fuels and commodity chemicals production via electrochemical methods at the Materials Research Society or MRS Spring Meeting 2021, and also organized 2014 International Conference on Conversion and Storage of Solar Energy held in Berlin, Germany. And so many experiences on chairing session. And then he also served as editorial board member of Nano Express IOP Publishing since 2019 and Molecules MDPI since 2018. Regarding research grant referee, he is a referee of U.S. Department of Energy, DOE, Office of Science, Funding Opportunity in 2021, and many more research grants. As journal referee, he also served as journal referee of many journals, including Nature Communications, Nature Energy, Nature Catalysis, Science Advances, and many more. Okay, and this is a long list of his publications. Total publications 97, age index 36, with total citations 6,825. And yeah, as I said, along of list of publications, including a paper on low bias photoelectrochemical water splitting via mediated trap states and small polaron hopping, published in Nature Communications with his colleagues and also a paper titled Transparent Porous Polymer Sheets for Efficient Product Separation in Solar Water Splitting, published in Sustainable Energy and Fuels in 2022, again along with his colleagues and many more papers. Okay, today, yeah, Dr. Fatwa Firdaus Abdi will be with us for around 45 minutes, and he will present a paper titled Photoelectrochemical Green Hydrogen Production. Right, Dr. Fatwa Firdaus Abdi, you have around 30 minutes, and then we will have discussion following that presentation. Dr. Abdi, time is yours.
Okay. Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Thank you very much for the kind invitations and also very kind introduction from the chair. Allow me to share my screen. All right. Is it visible?
Yes, it is.
Okay, good. All right, so thanks again. I'm happy to be here. And today I'm gonna talk about our work, share a little bit on our work on photoelectrochemical green hydrogen production. So as mentioned, I'm currently working at the Institute for Solar Fuels, Helmholtz-Zentrum Berlin. So if some of you are not familiar with this institution, is actually a research institute instead of a university. So we are part of research association, Helmholtz associations, maybe Max Planck associations or Fraunhofer associations are more popular elsewhere, but Helmholtz Association is actually the largest research associations in Germany under the Ministry of Research and Education. And we, Helmholtz Center Berlin, is one of the research center under this association that is focused on materials and energy. Okay, so today I'm going to talk about these three topics. So this is just the outline of my topic. First, I'm going to give a little bit of motivations why we are actually interested in renewables, and specifically in our case, why solar fuels. And then I'm going to give two examples of direct photoelectrochemical productions of solar fuels and chemicals, specifically hydrogen. And then the last part, I'm going to talk about a coupled approach in producing solar fuels and chemicals. All right, let's start with the beginning, and I think this is actually not too surprising anymore, that the main reason for the interest in renewables and renewables energy in the last few years or a few decades even is indeed the annual CO2 emissions that we have in the world that is skyrocketing, right? So if you see this plot over here, for the last, I don't know, almost 300 years here, we see that within the last 150 years, we have continuous increase of annual carbon dioxide emissions into our atmosphere. And it seems like a lot of efforts that we put doesn't really, do not really play into role. For example, here at the end of the 90s, we have the Kyoto Protocol, yet the CO2 emissions still rising. We have Paris Agreement just a few years ago in 2016, and the impact seems to be limited, so it's increased, and only we see the small dip when we have the effect of pandemic, right? But this is in fact only temporarily, because as far as I know, this year we're actually going back again to CO2 emissions higher than the level before. But there are a lot of talks, there are a lot of discussions on going to net zero by 2050. And if indeed we want to do that, you can really see the scale of the challenge here. So it's a global challenge of unprecedented scale. We have never faced this type of challenge before. We need to reduce from, we're increasing so much in 150 years, and we need to reduce to zero in 28 years. On the other hand, we keep emitting CO2. We keep emitting CO2 worldwide at a very high rate of about 1,400 tons per second. What does it mean? It means if you want to go to 1.5 degrees C, we want to limit the temperature increase to 1.5 degrees C. We only have a CO2 budget left of about 285 million. Translating that to time means we only have time of about 6.5 years, right? So this number I took in October, so now it's already a little bit less than that. So it's more or less 6.5 years that we can still emit CO2 at this rate, and then we stop to zero, right? And it has been argued that it's probably unlikely that we can keep the temperature increase to lower than 1.5 degrees C. The 2 degrees C is the next a feasible target that we can take. So if we want to limit to that, we also do not have too much time. We only have about 1 billion tons of CO2 budget left. And if we keep emitting the rate that we have today, we only have about 24 years of time. So this is also in line with the plot that I showed before, that we need to actually go to zero in 28 years, right? Yet another report out there. So there's a report in Science back in 2016 that mentions that if you want to limit global warming to less than 2 degrees C, we need to decrease it by 10 gigaton per year until around 2050. And that would limit the global warming to less than 2 degrees C. And in fact, even if we go to 1.5, and even right now, right, still less than 1.5, but we can already see a lot of the environmental impacts of global warming. So how can we do that? How can we actually decrease the CO2 emission? So I have over here a very simple empirical definition equation where it equates the total carbon dioxide emission with the population multiplied by the GDP per capita, or GDP over population, multiplied by the amount of CO2 that is emitted per GDP that is consumed, right? That's the per GDP. So in fact, it's very simple equations where you can just cross the population, GDP and GDP, and you get CO2 equals to CO2, right? So that's why I say it's a definition equation. So if you want to decrease the total CO2 emissions, one of these factors has to decrease. Unfortunately, it seems unlikely that the population will decrease, right? So its number keeps increasing, at least for the foreseeable future, in our lifetime at least. The number of populations is predicted to keep increasing. The GDP per capita, as countries, developing countries would love to go to be more developed, right? The increasing prosperity of different countries. It is also unlikely to see that the GDP per capita decreasing in the near future, right? GDP per capita is more likely going to be increased. So that only leaves us with this final term. So if you want to decrease the total CO2 emission, we need to decrease the CO2 per GDP, right? So now the question is, what is the relationship between CO2 and GDP? Unfortunately, it's actually not very promising. So if you take a look at this data here reported by Our World in Data in 2016, plotting CO2 per capita and GDP per capita, i.e. the relationship between CO2 and GDP, it seems like as this GDP increasing, the CO2 is also increasing, right? I mean, it's probably understandable, because as the GDP is actually increased, you want to actually use more products, and more products means, or more energy means, more CO2 emitted. Indonesia is somewhere there, and of course, as a country, we actually also want to increase our GDP, and if we follow this track, as we increase our GDP, we will also increase the CO2 emission. Another relationship here is between emissions and human development index. Indonesia is also somewhere there. And if we want to increase, of course, we want to increase our human development index. And unfortunately, according to this relationship, I mean, this is empirical relationship, then with increasing human development index, we actually have more emissions. The question now is, how can we break the relationship, or can we break it at all, right? So fortunately we can, right? So the question now is, how can, as a country, for example, Indonesia, we want to increase our GDP, but we don't want to increase our CO2 emissions. In other words, we want to move horizontally in this diagram here, right? So it's important to realize where this relationship comes from, and this relationship comes from the high dependence of our energy sector with fossil fuels, right? So that's why the more energy that we consume, I mean, the more GDP per capita, the more energy that we consume, theoretically, right, or generally, and the more energy is consumed. If the energy is coming from fossil fuels that is emitting CO2, it is not confusing that we actually have more CO2. So to decouple that, we have another, two simple equations, that the CO2 per GDP is equals to the amount of energy consumptions per GDP and the amount of CO2 that is emitted per energy consumption, right? So one of these two factors, or both factors, need to be decreased to decrease the CO2 per GDP. The first factor can be reduced by having more efficient use of energy, right? So you having less energy consumption per GDP. So not necessarily with increased GDP you have more energy consumption, right? Replacing any inefficient devices or inefficient technology with more efficient technology would be able to help you in decreasing this first factor. Whereas the second factor, the relationship between CO2 and energy consumption, we need to move to low or zero carbon energy source. And this is the reason why we're interested in renewable energy. So now I've hopefully established the interest or the need for renewable energy. The question remains, which renewable energy, right? So to answer that, I'll present several facts on renewable energy. First, the first fact, sunlight or solar energy is by far the most abundant source of energy. We have about 120,000 terawatts of solar energy on Earth, and about 1/3 of it is situated on land, right? To illustrate the abundant nature of solar energy, it's plotted over here, the power, the total power that you can get out of different renewable energy, hydroelectric, wind, nuclear, although it's not renewable, right? But put it here anyway, and then compare it with solar, and the solar energy. The assumption that I used over here is just that we're covering only 0.8% of the surface of the land with 10% efficient solar device. And even if we only do that, we can actually achieve already 30 terawatt, which is the expected demand of energy by 2030 or 2050. So it's clear, I hope, the abundant nature of solar energy, and to actually illustrate how large or how small the 0.8% of the surface of the land, we actually have the map of the world here, and 0.8% is actually the size of South Africa. Of course, we're not going to have all the solar energy conversion device there, but this is just to illustrate how little it is compared to the land area of the Earth. Translating that to Indonesia, Indonesia energy use, the number that I found for 2018 is about 250 gigawatt. So for that, we need about 20,000 kilometers square for the 30% solar energy conversion device. And just as a comparison, East Kalimantan is much larger, right? 130,000 kilometers square, and the size of this circle is enough for 20,000 kilometers square. Of course, as I mentioned, I'm not advocating that everything has to be there, but this is just to illustrate, right? Of course, this has to be distributed, and East Kalimantan, some of the area has been actually taken for the new capital, right? So we have to think about that. No, I'm joking. All right, so this is the abundant nature of solar energy. However, it's limited by one important factor, such as that the availability period of solar energy, unfortunately, is not the same as the peak period of energy demand. So solar energy, as sunlight, is subjected to several cycles. We have the daily cycle, right? So it rises and sets, right? And this peak of sunlight in intensity does not coincide with the peak of energy demand. We tend to have more energy requests or energy need in the early morning and early evening, and this doesn't, of course, this is the region where we don't have too much sunlight. We also have seasonal cycle, especially in countries or in the northern hemisphere or southern hemisphere, where we have the solar intensity here in black peaking around summer, whereas the demand is actually peaking in winter, right? So that we have this mismatch between the availability and demand. And of course, we also have weather fluctuations that actually would make this solar energy to be less reliable, right, than any other types of energy source. Okay, so that's the first fact. The second fact is that I would like to look at the storage option, right? So because this is also in continuation with the previous fact that I mentioned, because of this unavailability in all time, the logical solutions is that to store the solar energy. Now, if we look at the different storage, energy storage option, it's plotted over here in terms of specific energy and specific power. You can see that the chemical fuels by far have the highest energy and power densities among other storage options, including batteries or supercapacitors, right? And this is not too surprising because in chemical fuels or chemicals, right, you're actually storing energy in the densest possible form, which is the bond, the chemical bond between two atoms. So it's very dense. That's why we like our gasoline so much, because that's actually a very dense form of energy. All right, the final facts or more of an observations, situations at the moment, I would say that we have right now is that if you take a look at how we are consuming energy as a population in the world, right? Electricity use actually represents a minority. We only have about 20% of global average for our total energy consumption, right? Of course, the number differs for different country. For example, here Indonesia is about, I don't know, 15% in 2021 of electricity use, whereas a country like Norway has about 45%, but the global average is about 20%. What does it mean? It means that 80% is actually not in the form of electricity, right? So it's coming from chemical fuels where energy is stored in chemical bonds. So so it's clear that our infrastructure is now right now is suitable for using chemical fuels. And some sectors, even like chemical manufacturing, steel, cement, or aviations, are actually very difficult to be fully electrified. To give an illustration here, we have the aviation industry. So if you have the Airbus 350-900 ultra long range, the maximum takeoff weight is about 280 tons. And if you want to replace the kerosene, right, the fuels that it needs to actually fly this plane, and want to replace it with a battery, for example, if you want to use electricity to store a battery here, the mass of the battery alone is about 6,768 tons. So it's not going to work for this large flights, right? At least not at the moment. So this represents the need for chemical fuels. All right, that gives us into these three facts, right? Sunlight is the most abundant source. Chemical fuels have the highest energy density, and we're using fuels extensively right now. And I hope this allows you to actually come into conclusions that one of the most ideal solutions is if we can make fuels from sunlight. The question is, can we actually do that? Of course, the answer is yes, and that's in fact what the plants or leaves are actually doing in the process that we all know called photosynthesis. So plants take this carbon dioxide and water and form glucose, right? Some kind of sugar, and release oxygen, right? So this is a reaction that can be driven with solar energy. This is not the simplest reaction. One of the simplest reactions is water splitting, when you take water and split it into hydrogen and oxygen. And hydrogen can then be used directly as fuels, use it in a fuel cell or whatever, right? Or you can also use it to couple it with other reactions that we are already using right now, like Haber-Bosch synthesis of ammonia. You combine hydrogen and nitrogen in order to make NH3, ammonia, and ammonia is highly used in fertilizer production, right? Or we can also combine hydrogen and carbon monoxide in a Fischer-Tropsch reactor and make different types of hydrocarbons, methanol, diesel, and whatever, right? So, or you can also go directly using sunlight to do these reactions of CO2 and hydrogen and water to form ethylene, for example, or other hydrocarbons. How can we actually do that? Right now, we can already do that with two commercial devices called photovoltaics and electrolyzers, right? Photovoltaics take sunlight and transform it into electricity. So this is the indirect way. And the electricity is then passed over to an electrolyzer. And in electrolyzers, the chemical reactions or the electrochemical reactions is happening. So we have two devices. So it's nice, and two devices are mature, right? It's already commercial. But the problem is that with two devices, you can also higher cost because you have a lot of more components other than the active components, and that gives you higher balance of system costs. But this is already available now, and in fact, a lot of pilot projects, a lot of demonstrations are actually using this concept. But in the future, we think that we can actually go more towards an integrated fashion. So if we can integrate it, if we can integrate the photovoltaic and electrochemical functionality into a simple device called photoelectrochemical device, we might be able to go for lower costs because we reduce the need for a balance of system component. Okay, with that, I'd like to go to the second topic of direct photoelectrochemical production. So it's a continuation. So how does the direct photoelectrochemical productions happen? So we actually make use of semiconductor and semiconductor immersed in an electrolyte. And semiconductor has what it's called a valence band and conduction band. Valence band is an full of electron. Conduction band is empty of electron. And upon illumination of sunlight, electrons can be excited from the valence band to the conduction band. And if you do it properly, then electrons will go to one side and holes will go to the other side, right? So holes will go to the surface in this case, and electrons will go to the other side or the other electrode here. And then holes will then oxidize water to form oxygen, and electrons will reduce water to form hydrogen. The overall or the half reactions are shown over here. So this is the reactions at the counter electrode or the cathode in this case, and this is the oxidation reaction at the anode, and the overall reaction is water splitting, water to hydrogen and oxygen, right? This is not the only cathodic reaction. So we have the hydrogen production over here if we want to produce hydrogen, but there are also other reactions that are possible involving CO2 and water. You can make carbon monoxide, formic acid, methanol, ethylene, ethanol, propanol, and whatever, right? So depending on the electrode itself, you can tailor the reactions that you want. And as you can imagine from this diagram, the semiconductor plays a very important role, and it needs to fulfill several requirements, right? So it's listed over here. It needs to have a good visible light absorption. The band edge positions, i.e. the conduction and valence band, needs to be situated in a nice, in a suitable manner, so that it has enough energy to perform the oxidation and reduction reaction. It needs to have efficient carrier transport, efficient catalysis, high stability, and low cost, right? So these are a lot of demand on a single material, and right now there's no single material that fulfills everything. So we often have to make a combinations of different stuff. In our group, we focus predominantly on complex metal oxide semiconductors, and mostly because these are not the best semiconductors, but they relatively are more stable and they're relatively low cost. And we have to compromise on these other relatively lower properties. And that's why that's our research in trying to improve the property of complex metal oxides. And it can be done. So a success story for improving the performance of complex metal oxide can be seen in the case of bismuth vanadate over here. So this is a plot of photocurrent, which is the performance, right, reported for bismuth vanadate across many years, right, the last 20 years or so, by different groups, not only us. I mean, we reported here in Delft and Berlin. But many groups also reported and showed that in the past 10 years, because of this concerted efforts, we are able to increase the performance of bismuth vanadate very close already to the theoretical limit. In fact, we also constructed a standalone solar water splitting device, and we reported an efficiency of solar to hydrogen efficiency, right? I.e., how much hydrogen,
Excuse
how
me.
much how much hydrogen you produce in comparison to the solar intensity. We get a device of about 5%, and we also have a device of about 8% over here. This is regarding to the direct for electrochemical water splitting, and how does it compare with other? I mean, those are the stuff that we did. How does it compare with others? So we also have multiple aspects here. So these are the different devices, but it involves more than just bismuth vanadate. And as you can see, we actually can reach about 30%. So solar to hydrogen efficiency as high as 30% has been reported. This is using the indirect method, coupling photovoltaic and electrolyzer. But if we focus on just the direct method, we actually have a value that is very close to 20% over here. So the majority of the devices above 10% here are based on 3.5 semiconductors, and the 3.5 semiconductors are very good, very efficient, but it's very, very expensive. So it's unlikely that this will actually be implemented at a large scale. On the other side, oxide-based devices here show progress here, right? So the yellow one, but it has been stagnated since 2015, 2016. And the reason for this is a lot of them use bismuth vanadate. And as I showed in the previous slide, bismuth vanadate performance is already very close to the theoretical limit. So which means that further material improvement or discovery needed, right? So this is one of the big research topic in the field, trying to find a new materials that's actually performing as well as bismuth vanadate, right? But with more higher theoretical limit so that we can actually push this efficiency higher. All right, so that's a little bit on the direct water splitting. So I'd like to switch gear on my final, I think, 5 minutes on the coupled photoelectrochemical production of solar fuels and chemicals. So I've talked about the direct photoelectrochemical water splitting, right? But the question remains whether it is going to be competitive when we can actually reach higher efficiency, right? In order to assess that, people have done several techno-economic studies. So they have tried to see the feasibility of this PEC water splitting concept. And they have estimated that if you go through this PEC water splitting with whatever assumption, whatever boundary conditions that they put, they have a levelized cost of hydrogen in the order of about $10 per kilogram. So that's how much 1 kilogram of hydrogen will cost using PEC water splitting based on this analysis, right? To put that into perspective, we compare of the LCOH of hydrogen, right? The levelized cost of hydrogen using other competitive technology. Using fossil fuels method of producing hydrogen, which is steam methane reforming, we have about 1 order or a factor of 10 lower LCOH, about 1.4, 1.3 US dollars per kilogram. Even for from biomass gasifications, we have about $3 per kilogram. So it's still very expensive, this $10 per kilogram, and this techno-economic study shows that you can decrease this by increasing the solar to hydrogen efficiency. This is the most sensitive parameter, but it is still not expected to compete with this SMR hydrogen, even when the solar to hydrogen efficiency is 25%, right? So 25% is very high. And for metal oxide or low cost device, as I showed you, the highest that we showed is about 8 to 10%, and it's doubtful whether we can actually reach 25%. So this is a little bit demotivating for us because we're actually working on low cost metal oxide, and to know that even when the solar to hydrogen efficiency is 25% and it's still not competitive, this is makes us thinking that maybe other strategy can be introduced. And one strategy that we thought of is to actually couple photoelectrochemical hydrogen production with value-added chemical production. So the concept is the same. So we shine light into semiconductor, we generate hydrogen, and parts of the hydrogen is collected as hydrogen bubbles, hydrogen gas, right? But what if we can use some of the dissolved hydrogen part, couple it with the hydrogenation catalyst that is dispersed in the electrolyte and perform hydrogenation reaction of some kind of a feedstock to a valuable chemical, right? The example here is from CO2 to whatever chemicals that you want to produce, ethylene, for example, which is much more valuable than hydrogen. And the hope is that the higher market price of this product will then be able to compensate the hydrogen, and we overall the whole system will be more profitable. Some other technical advantages are listed over here, like matching rate between the hydrogen production and hydrogenation rate, the use of heat to enhance this hydrogenation kinetics, and most importantly, the flexibility to switch to other hydrogenation reaction, right? So because this hydrogenation catalyst is immersed or dispersed in the electrolyte, one can then simply replace the electrolyte without changing the solid component in order to target different valuable chemicals. For proof of concept, we have actually done experiment on this particular reaction. So we choose itaconic acid instead of CO2 as illustrated in the previous slide. Itaconic acid hydrogenations to methyl succinic acid. And why is this the case? Itaconic acid is one of the top sugar-derived building blocks, including glycerol, sorbitol, and whatnot, right? And if you hydrogenate itaconic acid, you will have methyl succinic acid if you do it properly. And methyl succinic acid is an important chemical used in polymer industry, solvent, cosmetic manufacturing, pharmaceutical, and many others, right? And it has a very high cost. And these hydrogenation reactions can also be done in conditions that are appropriate with this hydrogen production. So we set ahead and try to do this experiment. First, we try to test the catalytic hydrogenation. So this is a conventional hydrogenation of itaconic acid. You simply just introduce hydrogen at 1 bar and room temperature. And indeed, we can see that with the rate constant over here, we see that with increasing concentrations of itaconic acid and the catalyst, we see an increased production of methyl succinic acid. We then use these kinetic parameters and simulate the coupled reaction. So what happens if we couple it with photoelectrochemical hydrogen production? And indeed, the number is pretty promising. We get a expected conversion efficiency of about 40 to 50%, meaning that about 40 to 50% of the hydrogen that we produce is consumed to do the hydrogenation reaction, while the remaining is still collected as hydrogen. So we still have some hydrogen. So we did experiments, simple experiments where we just take this phosphate buffer and then add this itaconic acid as the feedstock and rhodium catalyst as the hydrogenation catalyst. And indeed, as soon as we do that, we see continuous productions of methyl succinic acid, as you see over here, and conversion efficiency as high as 60%, even better than our simulation, is demonstrated here. This is the coupled approach, and if we compare it with the direct approach, we see the additional advantage, right? Here we see constant increase of production, meaning that the production is not stopped or deactivated. Whereas if you go with the direct hydrogenations, the production is deactivated after about 2 hours. So our approach is much more stable. So this demonstration was done in dark, but we then do it also with solar driven. That's actually what we wanted to do, right? So then we do 2 different configurations with PV electrolyzer or the indirect configurations and the direct configurations. And in both cases, we see a productions of methyl succinic acid reaching a hydrogen to MSA conversion efficiency of about 50%. And we also have performed a net energy balance or life cycle analysis and techno-economic analysis for this. For the interest of time, I don't have the time to actually show it to you today, but hopefully this will be published soon. And our results are actually pretty promising that at this conversion efficiencies, we found that our approach is sufficient to be competitive even with respect to the steam methane reforming of hydrogen. So this is why we're interested to push this further. Okay, with that, that's the end of my talk. I will end with a few take-home messages. First of all, net zero carbon emission by 2050 is a challenging task, and it's an unprecedented challenge, and we must therefore act now. And the generations of chemical fuels from sunlight, I have argued as one of the ideal solutions. And in terms of direct photoelectrochemical water splitting, we need to develop cheap, abundant semiconductor materials, right, in order to improve the efficiency of the water splitting devices. And finally, we have introduced coupled reactions other than water splitting to increase the competitiveness nature of green hydrogen production. And today I showed the example of hydrogenation of IA to MSA. We have actually also worked on different type of hydrogenations like acetophenone or phenol and other types of reactions. With that, I would like to acknowledge, of course, my group members, the Institute for Solar Fuels, the people that are listed over here that are contributing to some of the works that I mentioned, some collaborators, funding agencies, and of course, thank you all for your very kind attention. I'd be happy to discuss any questions if there's any. Thank you.
Yeah, thank you very much, Dr. Fatwa Abdi. It's very interesting for us, and already been in the Zoom meeting, some scholars with, especially in, particularly in chemical or chemistry, chemical engineering background, educational background. So I guess there must be some feedbacks or questions. So for the audience, if so, please raise your hand and then mention your name and your institutional affiliation. Please. Any questions? Yeah, it's about the environmental thing, I guess, about how to have alternative for fuels. We already know so far. Maybe from Bu Anissa? Any questions, Bu? Yeah. Okay, thank you, Bu Anissa. Yes, time is yours.
Okay. Assalamualaikum warahmatullahi wabarakatuh. Thank you for the time, Pak Eko. I would like to ask a question. It is very interesting how you address the terminology. Previously, maybe the old terminology I heard is about solar energy. Right now, you mentioned it as a solar fuel. That is quite very interesting. But based on your opinion, Dr. Fatwa, in terms of the applications of the renewable energy, especially for the solar fuels, I think the advancement of the technology is quite proceeding. But however, based on your opinion, what is basically that become the obstacles of those application of those technology? Is it the technology or the political, maybe the political point of view? I think that would be all, Pak Eko. Thank you.
Yeah, thank you. Please, Dr. Abdi.
Yeah, thank you. Thank you very much, Bu Anissa, for the question. Of course, solar energy is a broader term, right? Whereas solar fuels is chemical fuels that are produced using solar energy, and that's actually the origin of the term. Right. In terms of the challenges that are remaining, there are a lot, and that's really coming from two fronts, like you said. So I would concentrate more on the technological nature, right? So the technological challenge, and that's really what's going to drive also the acceptance from the political how do you say parties or political people, right? The government or the society even, right? So if we can make the technology work and it's working at costs that is competitive, then I think that it's actually very difficult for the society at large to actually not look into the technology and implement it. Of course, there is also influence from the political nature, right? So, for example, to give you into perspective, right? So, I've been working in this field for about 13 years now, and 10 years ago, this topic of solar water splitting is actually very, very high, right? Very high. So there's a lot of efforts. People are actually looking into that. But sometime about 5 years ago, I think people are starting to leave the field and go to something else, right? Um, and 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 all of a sudden, a few years ago, there has been renewed interest on green hydrogen worldwide, right? Also here in European Union, Germany have this national hydrogen strategy. They put hydrogen as the forefront of the one of the potential solutions for their energy transition. And because of this decision, we all of a sudden have more research funding, more attention for hydrogen and solar water splitting. So that's also works hand in hand, but I would like to argue that if we from the scientific and engineering field could show that the technology is indeed competitive and feasible as a solution, then the other things will follow.
Any feedback? No. Okay. Thank you very much, Dr. Anissa Urrahma. Any more questions? Participants, please. Yeah, okay. I have actually several questions, Dr. Abdi, but maybe one only, and then let's see if there are questions from the participants. You said before that by 2050, net zero emission target. It's quite basic question actually. What if the target of getting zero on the CO2 emission is not met? And as always, I think, as always. And then, my point is referring to the past, what will happen? I mean, it is in my view that, okay, we still need to set the target, even though in the process we cannot meet the target, but it's kind of, guidance. And then we can do something. So, referring to the past, what will happen if the target is not met? Yeah, thank you.
Okay, thank you very much, Paiko. Yeah, so of course the first answer would be we should meet it because that's actually an important target, right? And that's something that we all have to strive for, and especially people at the policy level, right? So should not look this already from the beginning as something that can be it's not a soft target, right? So people, especially at the policy level, should look at it as a very hard target, as something that we should make it, right? And the implications, if it's not met, is that the global temperature will actually go higher than 2 degrees. So and that implications, IPCC have published several reports on what the world's expected, and these are based on a lot of renowned experts on what it will what will happen if the temperature goes to 2 degrees, 2.5 degrees, 3 degrees, and whatnot. And looking at the 3 degrees and 4 degrees, actually that's going to be a very different world than we're living in right now. And this is an experiment. I mean, this is, as I mentioned, this is unprecedented in our human histories, right? Or at least the known human history, right? So it is an experiment that we do not want to make, and at least I don't want to make and be there for the implications, right? So we have to to get it, and the implications is that, and like what you said, it's of course a target that we should strive to make. But even if we don't make it, but if we actually come close to it, that's already very good. And then then maybe we're not going to get the 2 degree but only 2.1. That's a lot better than not doing anything and then reach 4 degrees, right? And society, I mean, maybe one is pessimistic right now at how society can actually reach common target together, right? So seeing how divisive we are, maybe we are all pessimistic that this could happen. But in fact, we actually as a society have achieved some results in the past that are thought to be unachievable, right? So remember, maybe some of us that are a little bit older, more than 30 years old or so, remember that we had a problem before of these ozone layer depleting, right? So we have the CFC that has been used, and then all these gases that are actually out from to the atmosphere from coolant, causing the ozone layer to be depleted. And we don't hear that so much these days. And why don't we hear that so much these days? Because society have found a solution. We have tried to replaced this with something else. And I mean, I haven't really checked lately, but the last I heard about this is that the ozone hole and the thickness of ozone layer is actually getting back recovering, right? So this is a one example. There are also other examples. There's one example where we can actually come together and then solve global issues of this nature. And I do like to think that we should be able to also handle this other global challenge. I hope that answers the question.
Yeah, thank you. Thank you very much, Dr. Abdi. Any other questions, please, from the audience? Okay, it comes from from Dr. Heri Purnama. Dr. Heri Purnama, before you convey your questions, please mention your name as well as your institutional affiliation. Thank you.
Thank you, Pak Iko, for this opportunity. My name is Heri Purnama from Chemical Engineering, UMS. Simple question, I think. Now, according to your Dr. Fatba experience and knowledge, so what is the better technology that we need to develop in Indonesia, I think? Because at this moment, Indonesia, I think, focus more on the battery technology rather than hydrogen technology. So what of the thing is for the hydrogen, but it's different thing maybe. I don't know, it is about a political issue or something like that. But according to the technology and the maybe the best energy for the future, what is your opinion about this? Is with hydrogen or the battery? Okay, thanks very much. Yeah.
Okay, thank you very much, Pak Heri, for the question. Yeah, so of course this is a very difficult question because there's really one, I don't because of a number of things. One, I don't think I have the necessary knowledge to answer for the Indonesian market or Indonesian future, right? So I don't think I have that knowledge to make that decision. And two, if you compare these two technologies, their battery and hydrogen, they're not necessarily. I mean, they're always, or not always, often in the media or in the debate, it's often pictured as technologies that are competing with each other, but they're not necessarily competing with each other. Each its own, right? So battery technologies have its advantage. Hydrogen or chemical fuels also has its advantage and disadvantages, right? So battery needs to be probably more efficient for low transport, or how do you call that? Low freight transport, where maybe for high demanding transportations like I showed today with the aviations, right? So it's going to be very difficult for battery, and there where's the chemicals come in. And there's a lot of issues. There's a lot of technologies rather than just transport, right? So I mean, vehicle transport only contributes to a certain part of the carbon dioxide emissions. Maybe if you can cover that with battery, that's great. Yeah, let's do it. And of course that's what should be done. But there are also other types of applications that cannot be addressed by just battery technologies, and for that maybe hydrogen or maybe other chemical fuels combined with whatever other technologies will actually make into a better option. And to answer into maybe just a little bit into the political nature, right? So which ones should Indonesia or any other countries basically do, right? This is all also related to the infrastructure, right? So for battery technologies, then you need to have, depends what you want to do. You need to have infrastructure of electricity that's actually have a high penetration, right? And then you have the batteries situated, whatever it is, right? So for places that do not have high electricity penetrations, this is then a moot question. So it's really not the best option. And then for chemical fuels as well, right? So do you really have the infrastructure to bring chemical fuels from one place to the other, and is this actually feasible or is this economically feasible or not, right? So it's much more probably easier to transport chemical fuels than electricity in places that do not have electrical grid, for example, right? So you can just use an older mode of transport, not necessarily cheaper, but it's possible, right? For example, here when we have pipeline, right? In Europe we have pipeline to transport gases, right? Then the political decisions also takes this into considerations that, okay, we already have this infrastructure. That's why we probably we will be able to integrate this more into this. But it also doesn't mean that they actually do not put a lot of efforts on batteries, right? So they also have some activities on that one as well, even more activities on that one. So both, I would say, have to be done. If you need to prioritize that, I would look into where do you want to implement this and what type of infrastructure is already there. Do you have enough electricity to actually go for battery? Right? If you are coming in with I don't know, thousands or tens of thousands of battery car, but then you don't have enough charging station, that's also an issue, right? So these are all interrelated factors, I would say. I hope that somehow answered the questions, although I understand it's not. I could not really give a very definitive answer for this.
Okay, thanks very much.
Any feedback, Dr. Purnama?
Okay, that's all. Thank you. Yeah.
Okay, thank you so much. So the forum gets much warmer actually, but as we realize together that time availability limits us. So thank you very much, everyone, all participants, for joining this session. And for Dr. Abdi, we have a certificate of appreciation. So please, the committee to display the certificate. Yeah. Yeah, this is a certificate for Dr. Fatwa Firdaus Abdi as keynote speaker in the event of Icetia 2022. Again, for all participants, thank you very much, and especially for Dr. Fatwa Firdaus Abdi, please allow me to express on behalf of the Icetia and Rapi committees, please allow me to express our gratitude and thankfulness. And we really do hope to all participants, particularly Dr. Fatwa Firdaus Abdi, to be able to join us in the future. Thank you very much. And to end this session, please give big applause to Dr. Fatwa Firdaus Abdi.
Thank you very much also from my side. It's my pleasure to be here, and I hope whatever I shared is useful. And
yes.
I look forward to meeting you in person next time.
Yes, of course. Yeah, thank you so much. And from me, Assalamualaikum warahmatullahi wabarakatuh. Again, thank you so much for everybody have been already joining this session.
Thank you to Mr. Eko Setiawan, STMT PhD, who have guided in this panel session too.
Next agenda, there will be parallel session. For all participants who follow this parallel session, please join at the room breakout that has been opened by operator. And don't forget, for all participants, there will be a short course tomorrow for day 2. It is about introduction to safety software, effect and risk curve that will be delivered by our great speakers too.
We would like to thank you and apologize previously if there are words that are not pleasing to the audience, because all truth, perfection, and beauty belongs to Allah Subhanahu wa Ta'ala. And let's close today's program by saying Hamdalah together.
Alhamdulillahirabbil alamin.
I am Muhammad Arhab Atorik and my partner
Mira Septikawati
as a Master of Ceremony ended over here. See you in the 10th of Icetia International Conference on Engineering, Technology and Industrial Application.
And the 22nd of Rapi, Rekayasa Aplikasi dan Perancangan Industri 2023.
Wabillahi taufik wal hidayah. Wassalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh.